We can start this session.
The professor.
Hello, good morning all. Hello, good morning all the professors.
Good morning, madam.
Principal,
Good morning.
sir. This is Dr. G. Sirisha from Department of Statistics, University College of Science, Osmania University.
Yeah, welcome, madam. Good morning. Yeah.
Good morning, one and all. On behalf of the Department of Statistics, University College of Science, Osmania University, I welcome all the dignitaries, speakers, and the participants for today's inaugural function of the one-day pre-conventional workshop, International Virtual Workshop on Innovations on Data and Statistical Sciences. Hope I can start, sir.
Yes, madam.
Yes, please go ahead.
Yes, sir. Yes, sir. Now I invite Professor A. Balakrishna Garu, Dean Faculty of Science, Osmania University, to occupy the chair. I invite Professor B. Veeraya Garu, Principal, University College of Science, Osmania University, to occupy the chair. I invite Dr. N. Balakrishna Garu, Senior Professor, ISPS President, and he is a professor in Department of Statistics, Cochin University of Science and Technology, Cochin, Kerala.
Yes.
I request sir to occupy the chair. Now I invite Professor S.C. Malik Garu, Department of Statistics, Maharshi Dayanand University, Rohtak, Haryana.
Thank you, madam. Thank you.
Rohtak, Haryana, and he is ISPS General Secretary to occupy the chair.
Thank you.
Thank you, sir. Now I invite Professor Rajshekar Reddy Garu, Honorary President of ISPS and Professor in Sri Venkateshwara University, Tirupati, Andhra Pradesh, to occupy the chair. Now I invite Professor G. Jayashree Garu, convener of the workshop and Vice Principal of University College of Science, Osmania University, to occupy the chair. I invite Dr. N.C.H. Bhattacharyalu Garu, Head Department of Statistics, University College of Science, Osmania University, and the Organizing Secretary of this workshop, to occupy the chair. I invite Dr. S.A. Jyotirani Garu, Chairperson, Board of Studies, Department of Statistics, University College of Science, Osmania University, to occupy the chair. Now the program will get started with the prayer song by Sri Harini.
महागणपतिं मनसा स्मरामि महागणपतिं मनसा स्मरामि महागणपतिं मनसा स्मरामि महागणपतिं मनसा स्मरामि वसिष्ठवामदेवादिवन्दितमहागणपतिं महादेवसुतं गुरुगुहनुतं महादेवसुतं गुरुगुहनुतं महाकाव्यनाटकादिप्रियम् महाकाव्यनाटकादिप्रियं मूषिकवाहनमोदकाप्रियं महाकाव्यनाटकादिप्रियं मूषिकवाहनमोदकाप्रियं महागणपतिं मनसा स्मरामि वसिष्ठवामदेवादिवन्दितमहागणपतिम्.
Thank you, Sri Harini. Now I request Dr. NCH Bhattacharya Garu, Organizing Secretary and Head of the Department, Organizing Secretary of ICSDS 2021 Pre-Conventional Workshop, to give his welcome address.
So please unmute.
Good morning to all. The respected chief guest, Professor Balakrishna Garu, Dean Faculty of Science. Respected on the Principal, University College of Science, Professor Veeraya Garu. Respected Professor N. Balakrishna Garu, President ISPS and Senior Professor, the Posted University of Science and Technology, Professor S.C. Malik Garu, Maharshi Dayananda University and General Secretary for ISPS, and Professor Rajsekhar Reddy Garu, the Honorary President of Indian Society for Probability and Statistics, and Professor G. Jayasri Garu, Professor, Department of Statistics and Vice Principal, the University College of Science, and convener of this workshop, and Dr. S.A. Jyotirani Madam, CBOS, University, and respected the professors, senior professors, and the delegates. So here I am welcoming to all the participants. So I'm very much thankful to all the participants and the Society for Probability and Statistics for giving this wonderful opportunity, and it is honoring the Department of Statistics by hosting the Indian Society for Probability and Statistics, the pre-conventional workshop in the Department of Statistics. But unfortunately, whatever the situations of the COVID, so we are not in a position to conduct in offline mode as per the previous schedule that is announced by the Indian Society for Probability and Statistics, and that was converted to the virtual mode. And I'm thankful to all for your kind cooperation in the same regard. The subject of the statistics was introduced in India in 1944 by Prashant Chandra Mahalanobis in Calcutta. He started a small institute offering a diploma course in statistics initially. In course of time, that institute has grown up remarkably. It is nothing but Indian Statistical Institute, Calcutta. The Osmania University introduced the master degree in statistics in 1959 under the Department of Mathematics under the dynamic teachers Professor Pakshirajan, Raghavendra Rao, Professor Narasimha Reddy in 1961. It was came to with the first batch, and these classes used to be held in the aim of inspiring the Arts College building, the Osmania University. So a renowned professors of this department, Dr. M. Sudhakar Rao, the first batch of this university. And on the request of Honorable Vice Chancellor, Professor P.V. Ramchandramurthy from Alberta University, Canada, has joined in Osmania University and established the department on December 8, 1966. In the same year, the statistics subject was introduced at UG level in the evening colleges, and Dr. P.V. Ramchandramurthy left for Canada as an associate professor in the Department of Mathematics, Alberta University, Canada, and the later Professor V. Subhadra Devi Madam. In 1970, she joined in the department, and also under her dynamic leadership, the applied statistics course was introduced in the Department of Statistics. And many of the professors, Professor Narahari Pandit is joined in the Department of Statistics as a professor in 1978, and later he produced many of the PhDs from the Department of Statistics, Osmania University. And the Department of Statistics produced around 80 PhDs till now, and around 65 MPhils, and around more than 50 batches of the MSc, that means post-graduation students, and who are across the globe, they are working. And many of them are in very higher positions. And previously, Professor Ramalinga Swami sir has also playing a key role in the ISPS society. And the Department of Statistics, Osmania University, was grown and is funded by many of the research projects under DSP phase and SAP phase 1 and phase 2. And also the department has conducted many of the national and international conferences under the dynamic leadership of the senior professors like Professor V.V. Haragopal sir and Professor Sudhakar Rao garu, Professor P.V. Ramchandramurthy garu, and Professor Ramalinga Swami garu, and Professor Krishna Reddy garu, and many other the senior professors in the department. So it is our pleasure to host the pre-conventional workshop in the Department of Statistics in collaboration with the Indian Society for Probability and Statistics. So thank you. Thank you for giving opportunity to the ISPS organizing executive committee for the chance. Thank you, sir.
Thank you, sir. Now I request Dr. S.A. Jyotirani Garu, Chairperson, Board of Studies, Osmania, Department of Statistics, Osmania University, to address the gathering.
You are muted actually. You have to unmute yourself.
Yeah, sorry. Hello, am I audible, sir?
Yes,
Yes,
madam,
yes, yes.
Yeah, good morning, everybody.
Yeah, good morning.
And that is today's workshop, and my dear participants, the respected dignitaries. So, Professor Balakishan Garu, Dean Faculty of Science, today's chief guest of this workshop, and Professor B. Veeraya Garu, Principal, University College of Science, Usmania University, and President of today's workshop, and Professor N. Balakrishna Garu, ISPS President, Professor S.C. Malik Garu, ISPS General Secretary, Professor P. Rajshekar Reddy Garu, Honorary President ISPS, Professor G. Jayashree, ISDS 2021 Workshop Convener, Professor N.C.H. Bhattacharyalu Garu, Head Department of Statistics and Organizing Secretary ICSDS 2021. So first of all, thank you very much for giving me this opportunity. So to share a few things with you. And we are in the era of artificial intelligence. So the data, so which is the key to the central nervous system of global applications like in finance, healthcare, so business, economy, etc. So this data is very crucial to the public finance system, market research, healthcare, stock exchange, market analysis. So that is for taking the decisions. So this innovations, so on data, so here statistics plays a crucial role in this. And as part of this, so I would like to share that. So what is actually that we do with the data? Because the plenty of data so is available for us for the analysis. So it may be of the structured data, unstructured data. So terabytes and gigabytes of data is available. So that so for everything, so the analysis is required for making any decision. So for that, very first thing is, so one should need to understand the problem. So the what are the relevant questions of that problem, and so understanding of that problem, and what are the tools or so the subject so that is required so to handle the data. So as part of this, the very first thing is, so one should gather the data. Data gathering is very important. So this data gathering, so it may be through web servers, so logs or databases or any APIs, that is application information. So that is the interface system, and so online repositories, so etc. So once the data is gathered, so the data is to be prepared. The data preparation is very important. So as part of data preparation, so data cleaning and data transformation, so is very important. So in data cleaning, so that is it is the most time consuming process. So that is any inconsistent data is there, so we need to identify, and misspelled attributes are there, so one should need to so verify properly. And sometimes so missing or duplicate values are there, will be available, so that it should one should go through that thoroughly. So once the data is cleaned, so in the database system, so then so data transformation, so this data transformation can be done so using, so that is a modifying of the data in the database. So it uses the ETL tools, any of the ETL tools, that is so extract, transform, and load. So using Talent or Informatica, so it helps users to understand the data structures. So for further process. So once this stage is over, so then the next stage, so which is very important that, so what to do with the data. So that is very important. So that exploratory data analysis is required. So in this, so that is defining and refining the selection of feature variables, and those variables will be used in the model development. So this will plays a crucial role for developing the model. And in the next step, so after this, so we need to go with the data modeling. So this data modeling, so it may be done with so any of machine learning techniques, so or deep learning techniques, so or the classical methods, so whatever it may be, so that is suitable for so data. So it is to train the data set or test the data set. So for selecting the best performing model. So for this we can use so the Python or SAS, so so any programming code or any statistical software. So for data modeling. So then, so data visualization and communication. So it may be done through Power BI, Tableau, so ClickView, so or Python, so etc. So after that, so that is the data deployment is very important. So deployment and maintaining the so model. So that so this can be done so to the production environment. So the deployment is to be done to the so production deployment. So once it is deployed, so that is a one can that is a using the reports and dashboards. So for real-time analysis, so to maintain the project performance. So therefore, so here, so for this entire process, so that is a data scientist or data science. So is challenging. So in nowadays, that is today's world. So in different applications like healthcare system or medical system, so it may be of finance, economy, so transport system, so like airways, airlines, so different applications. In most of the applications, so we are using this only. So that the advanced techniques are there. So advanced models are available. So for handling the so that so structured data also nowadays. So that is using machine learning or natural language processing. So to analyze the so structured data also. So that so we need to update ourselves, and so that is for analyzing the data. So for all this, so the base is so that is statistics knowledge is very important, and which plays a crucial role. So that entire process, so that it is not only of that one can need so to become a data scientist. So one so the knowledge of mathematics, computer science, statistics is very important. So it is the data science is the intersection of all these three. So that so one should that is with the knowledge of all these, so to advance so for future applications in the era of artificial intelligence. So thank you very much for giving me this opportunity so to share a few things with you all. Thank you very much.
Thank you, madam. Professor G.J. Sonia, about.
I think there is some problem with the network, I believe.
Madam, they clear the route. Chakra.
Yes, thank you, madam. I think there was some problem. Sorry for the disturbance. Thank you, Jyotirani madam. Now I request Professor G.J. Srigaru, Vice Principal, University College of Science, Usmania University, Convener, ICSDS 2021, Pre-Conventional Workshop, to speak about the workshop.
Good morning. Am I audible?
Yes, madam.
Yes,
Good
you
morning.
are audible. Yeah.
Thank you, sir. A warm welcome to all the dignitaries on the dais. Our honorable chief guest of today's function, Professor A. Balkishan, sir, Dean Faculty of Science, Usmania University. Our beloved principal, sir, Professor B. Viraya Garu, Principal, University College of Science, Usmania University. Respected Professor N. Balakrishna, sir, Senior Professor in the Department of Statistics, Cochin University of Science and Technology, Kerala, and President of ISPS, Indian Society for Probability and Statistics. Respected Professor S. E. Malik, sir, Department of Statistics, Maharshi Dayanand University, Rohtak, Haryana, and General Secretary of ISPS. Respected Professor P. Rajshekhar Reddy, sir, Retired Professor of Department of Statistics, Sri Venkateshwara University, Andhra Pradesh, and Honorary President of ISPS. Dr. N.C.H. Bhattracharyulu, sir, Head Department of Statistics, University College of Science, Usmania University, and organizing of this pre-conventional workshop. Dr. S.A. Jyotirani, Chairperson Board of Studies of Department of Statistics, Usmania University, and respected senior professors, delegates. It is our pleasure and privilege to welcome you all to this pre-conventional international workshop on innovations on data and statistical sciences, which is jointly organized with University with Indian Society for Probability and Statistics. As all of us are aware, there is an explosion of data around us. Data science and big data are transforming our world and touching our daily lives like never before. So these are comprised of machine learning and artificial intelligence techniques. This data can be handled through these particular techniques. We can even observe that the augmented reality and virtual reality aim at enhancing the interactions between the human and the machines. They automate data insights with the help of machine learning and natural language processing, which facilitates data scientists and analysts in finding patterns to generate shareable data. So universities have responded to this increased need for talent in this field by introducing e-learning courses on data science for learners and of all backgrounds. In the same aspect, we have designed this workshop and hope that this will surely enhance the knowledge of the participants. I am sure that this is a platform where the speakers can deliver the lectures and they can impart their knowledge to the audience, and the audience or the delegates or the research. I'm very sure that they are going to gain a lot of knowledge out of this particular workshop. So I thank all of you for giving me this opportunity. Thank you.
Thank you, madam. Now I request Professor N. Balakrishna Garu, Senior Professor, ISPS President, to address the gathering.
Okay, respected dignitaries on the dais, Professor A. Balakrishna, the Dean, Professor Veeraya, the Principal, Dr. Jyoti Rani, the Chair of Board of Studies, Professor S.C. Malik, the Secretary of ISPS, Professor Ashek Reddy, the Honorary President, Professor Jayashree, Convener of the Conference, Professor Bhatracharilu, the Head of the Department, and all delegates, good morning to you all. So, very outset, on behalf of the Executive Committee of ISPS, I welcome all of you to this workshop on innovations on data and statistical sciences. So, when I took the previous speakers, that is Dr. Jyoti Rani and Dr. Jayashree has already given an elaborate description about the workshop and the motivations and the need for this workshop and how this came to this shape and so on. In fact, initially we have planned this workshop offline along with the conference of ISPS, which is yet to start tomorrow. But due to the present scenario, as we know, all of us are aware of, this has been converted to the online mode. But still, I'm happy to note that there are several participants who have registered for this workshop, and I'm sure this will be a grand success. So I take this opportunity to congratulate the conveners of the conference, that is Professor Jayashree, Professor Bhatracharilu, and our honorary president, Professor Ashek Reddy, who took a lot of interest in materializing this workshop. I'm sure all these participants will be definitely benefited by participating in this workshop. And if you see the list of speakers, there are several well-known speakers in different areas of current interest. I'm sure all of you will be happy about this and will get benefit out of this. And without extending much, I think we are already beyond schedule. So finally, I wish the workshop very success, and we will be waiting for the different proceedings of this workshop. Thank you for giving this opportunity.
Thank you, sir. Now I request Professor S.C. Malik Garu, ISPS General Secretary, to address the gathering.
Yes, a very good morning to all of you. And it is a great privilege for me to be part of this annual session of the pre-convention workshop. As on today, the theme of the workshop is very much relevant for the needs of the society, for the needs of the industrialist, for the needs of all. And at this occasion, it is very great moment for me to thank the organizers to take keen interest to organize such type of workshops in a very difficult situation. Although they were planning to conduct the workshop or the coming conference through physical mode, but due to the difficulties, all we know, they tried their best to conduct the programs online. So I congratulate the entire team and thank to the university, thank to the organizers for taking interest to conduct this program through online mode. So I hope that the participants will definitely get benefits through this workshop, and they will try to utilize the statistical tools in the age of data science. So congratulations to all of you. I welcome all the participants as Secretary of ISPS. Thank you all of you for providing me this opportunity. Good morning to all again. Thank you.
Thank you, sir. Now I request Professor P. Rajshekhar Reddy Garu, Honorary President, ISPS, to address the participants.
Distinguished dignitaries of the Osmania University, workshop participants, faculty members, research scholars, ISPS executive members, organizing committee of the 41st ISPS come workshop. A very warm welcome of the workshop. It gives me an immense pleasure, and I am really delighted to be a part of this very auspicious inaugural program of the virtual presentation workshop on innovations on data and statistical sciences for the benefit of faculty, research scholars as a part of its ISPS annual convention. The workshop will have deliberations on the topics of statistical sciences and data science, which are intended to provide a platform for research scholars, faculty members, and to know the latest advances in the fields of specializations for their better academic pursuits. Interactions of expert and young scientists with the students is another objective of the workshop. I am also grateful to all the speakers, Professor Ashish Kumar Chakravarti, Professor S. Dharmaraja, Professor Anup Chaturvedi, Professor Somesh Kumar, Professor Ravi Subudhi, Professor M. Krishna Reddy, Dr. K. Srinivas, Professor Surendra Kumar, Dr. R. Vishnuvardhan for accepting our invitation. So this is so here a part of our ISPS. Regularly we are organizing the workshops for the benefit of our research scholars. So this is now every pre-convention workshop. It is almost. So now I'm also congratulating the organizers, the Bhadracharya Garu, the organizing secretary, and Jayasri, and the entire team. So thank you for giving an opportunity to say a few words. Thank you.
Thank you, sir. Now I request Professor A. Balakrishna Garu, Dean Faculty of Science, Usmania University, the chief guest of today's function, to address.
Yeah, you are muted.
Please unmute, sir.
Hello, am I audible?
Yeah, you're audible.
Thank you. Thank you, my dear organizers of the wonderful workshop from Usmania University. Respect all the dignitaries who are taking part in this August gathering. And my special appreciation, my special thanks and invitations to all the resource. My dear colleagues in the Department of Statistics, research scholars, dear students, it gives me great pleasure to be amongst you this morning. I'm really happy to be associated with you all for the simple reason that the Hyderabad is known for its minars and seminars. And it's been a long time since we have conducted any kind of regular mode conferences, workshops, and this COVID has taught us to search for alternative methods of conducting programs, be it classes, seminars, workshops, conferences, even PhD vivas. But now, since the things are coming under control after this post-COVID dangerous situation, while I am happy, extremely happy that the Department of Statistics conducting a wonderful workshop, but however, there is a small pain in my heart somewhere that, Usmania University is known for its wonderful hospitality. Those who ever visits our Usman University, they cannot forget the hospitality we provide here. Now, in the given circumstances, we are conducting this program online. I wish we could have conducted this program in a physical mode so that we would have also had the opportunity of seeing so many wonderful people who are taking part online today. We would have met them. And not only that, we would have provided them wonderful hospitality of our Usman University specialty. Not only that, probably we would have taken them for a sightseeing of Hyderabad city, and there are certain wonderful places nearby Hyderabad city like Ramappa, which has been recognized as one of the heritage city, heritage centers by UNESCO recently. So anyway, with that little bit unhappiness, but I am confident that within a short span of time, this department will definitely come up with a new program of conducting a international seminar where we can invite wonderful personalities across the globe so that we can meet them physically, we can chit chat, we can share our knowledge, and ultimately our intention is to transfer the knowledge of these experts to our younger budding students. This is our motto. Now, as several speakers before me, they told the importance of this workshop. Yes, I do agree. The science and technology is changing day by day. What we have seen yesterday is becoming irrelevant, and things are coming in front of us with posing new challenges, new questions. Similarly, the statistics, earlier statistics subject is under metamorphosis, under lot of changes day by day. And now we talk about data sciences, intelligence, artificial intelligence, and computer applications in almost all fields. You take, e-commerce, e-business, Amazon, whatever. These are the techniques. These words are becoming buzzwords now. Without these words, things are becoming very, very difficult to understand the present situation, social situation. Now, recently I have come across in Hyderabad city, there is a lot of shortage for statistics students. I was really surprised to see that, there are colleges. We are, though as a dean, faculty of science, I was happened to visit certain colleges where the people are ready to start statistics subject in PG level, but they are finding very, very difficult to find hands, new teachers who have completed their MSc statistics. And I understand this is a very rare subject, and in not many other universities are offering this statistics subject. So I strongly believe that this is one of the emerging subject, and where immediately one can find job opportunity the moment before he completes his PG. So this is the very rare opportunity. Unlike other subjects in science, after completing their subject, their MSc post-graduation, still people are waiting for, some new opportunities, new job opportunities. But in statistics, it is totally different. And with these few words, I'm really happy to be amongst you. I wish all the best. And I strongly believe that this forum will definitely help all our younger minds to interact with seniors, and they will definitely get the knowledge from the seniors through their expertise. And not only that, this is a wonderful opportunity to listen these eminent personalities, and so that they will also establish a kind of wonderful contact, so that in future they will be in touch with them, and probably they will also try to invite them to our Usmania University. With these few words, I am really happy. I am lucky enough to be amongst such a great stalwarts who are taking part in this. And because, time constraints, I am not able to take each individual name, but I am really bow my head before each one of you. And you really showed the importance of Usmania University Department of Statistics. And please do try to visit our Usmania University. I am willing to extend hospitality. And thank you very much. I wish you all the best for successfully organizing this seminar. Thank you very much. And finally, I suggest my head of the department, Board of Studies, and Professor Jayashri, Vice Principal, to all the papers, all the presentations in a book form that will be useful to the students and research scholars for future generation. Thank you very much.
Thank you, sir. Now I request Professor B. Veeraya Garu, Principal, University College of Science, Usmania University, to give the presidential remarks.
Very good morning to all of you. So on the occasion of free conventional international virtual workshop on innovations on data and statistical sciences, the chief guest of this today's function, Professor A. Balakrishnan Garu, Dean Faculty of Science, Usmania University, and Professor N. Balakrishna, Senior Professor, ISPS President, and the Faculty of the Question University of Science and Technology, Question, Kerala. Professor S.C. Malik, the Faculty of Department of Statistics, Maharishi Dayananda University, Rohtak, Haryana, and ISPS General Secretary. So Professor N. Balakrishna Garu, Senior Professor, and the Professor N. C.H. Bhattacharya Garu, Head Department of Statistics, Organizing Secretary, ICSDS 21, and the workshop on innovations and data science, statistical data sciences. So Professor Jayasri, the Faculty of Department of Statistics and Convener, ICSDS 21, and the Vice Principal, University College of Science, Usmania University. Professor Rajashekar Reddy Garu, Honorary President, ISPS, and the Faculty of the Sri Venkateswara University, Tirupati. A warm welcome to all of you for the innovations on data science and statistical sciences, an international workshop which has been convened by the Usmania University faculty members. It's a very happy occasion that all the data science is coming to the Hyderabad. So you are very well aware the Hyderabad, it's becoming the capital of the information technology. On this occasion, all the data science, the faculty members and the researchers and the students, and all of them they were eagerly waiting for the new upcomings in the data sciences. All these, the speakers, the participants, and the students who are participating for the next 2 days will get benefit out of this, the workshop as well as the international conference on statistical data sciences. If you look into the life, the human beings, everywhere the data science is used whether knowingly or unknowingly, all the public, it is used by the data science, and that is driven by the statistical sciences in the background. I wish all the participants of the workshop and the resource person to the workshop to have the interaction between the youngsters and share the knowledge to the younger minds for the benefit of the younger ones as well as the country for the data from the data science. I wish you all the grand success of this workshop and have the fruitful outcomes out of this workshop as well as the international conference which has been planned. So on this occasion, so I'm feeling very proud to participate in this inaugural event of this workshop. Once again, I wish you all the participants and for the grand success of this workshop. And thank you for giving this opportunity to speak with you a few words. I'm thankful to you for the organizers. Thank you very much.
Thank you, sir. I thank all the dignitaries, speakers, and participants for attending the program and making it a success. I thank the video technologies for their support. I thank the faculty teaching and non-teaching, research scholars, student volunteers of the department for their support. Thank you. Thank you all. Within 2 minutes, we'll start the invited talks sessions. Thank you.
Thank you. So,
Thank you. Thank you all.
Thank you, madam. Thank you. All the best wishes.
Thank you, sir.
Thank you. Thank you.
ఆశీష్ కుమార్ చక్రవర్తి చేయాలి. ఉన్నారా?
Yes, yes.
Sir, shall we start the sessions?
Oh, yeah. Please go ahead.
Okay, thank you, sir.
Because the speaker is seen on the screen.
The first speaker of today's workshop is Dr. Ashish Kumar Chakravarti, sir. Sir is a recipient of prestigious PC Mahalanobis Award, award for his contributions in statistics, mathematics, and related disciplines. Senior faculty of Statistical Quality Control and OR Operations Research Division in Indian Statistical Institute, Calcutta. And we welcome you, sir, for this particular talk. and it is my privilege to introduce Sir for this particular session. Sir is a certified auditor for ISO 9000 quality system requirements, and Sir is a certified auditor for QS 9000 quality system requirements. Sir is a member of many professional bodies. To name a few, life member of Operational Research Society of India, life member of Indian Association for Productivity, Quality and Reliability, served as an honorary member of the governing body of IPQR and other organizations as well, and serving as a member of the governing council of ORSI, life member of Indian Statistical Institute, serving as a member of the governing council of ISI. And Sir's research interests are in reliability, software reliability, process control, interface between statistics and machine learning, which is the need of the hour. And Sir is a consultant for Indian Space Research Organization, Coal India Limited, and even to Government of Gujarat. And to name a few of the achievements of Sir, Sir published and edited 9 books and was the guest editor of one special issue of OpSearch. He has also contributed chapters in 4 other books, published over 70 research papers, and guided several students for PhD apart from research. Served as chairman or member of many statutory and administrative bodies of ISI, and as the coordinator of a nationwide project named Quality Mission Project under the aegis of Government of India. I welcome you, sir, to this particular workshop, and it is our privilege to have you here on this day. Please welcome, sir.
Thank you. Thank you for a detailed introduction. And I am really thankful to Professor Rajasekhar Reddy for inviting me for this program, and also to the organizers of this workshop and the conference. I see a lot of friends present here, including Professor S.C. Malik, Professor Balakrishnan, Professor Dharmaraja, and many others. So hi to all my friends, respected dignitaries, and good morning to all others. Yeah, I'll start with the basic question that has been running around is what is data science or what is data analytics? So today's discussion, I will try to keep on that, because I could see, based on my limited experience of about 38 years in both teaching and consultancy, a lot of people are defining many things in their own way. So I'll just try to highlight some of my experiences, of course, based on data, and hopefully it will be quite useful for the participants. Are you able to see the screen?
Yeah.
Yes, Professor.
Yeah, okay. So data science or data analytics, what is that? In fact, I could see that most of the jobs available now is data scientist job. And as Professor Jyoti Rani has mentioned already, that a lot of new problems have come, because of which new methods were required. And I'll just go through some of my experiences, how I also entered into this. Though I have been trained as a statistician in Indian Statistical Institute, but still we have to go beyond statistics into data analytics and also data science. So I'll just try to give some, try to throw some light on this. Yeah, we already know, in fact, Professor Jyotirani has already mentioned that different types of data are nowadays available, which when the statistics was being evolved, that many different types of data were not available. But right now, the data, you can imagine any kind of data becomes a data. Any kind of information becomes data. So starting from categorical, like good, better, best, or yes, no type of data, continuous type of data like temperature, pressure, etc. Text data, in fact, some people call it as text analytics, like if somebody wants to do some research on the orders given by our Supreme Court, that is basically text. Different literature and many other things. Pictures like satellite images, these are become very important data nowadays. So that needs to be properly analyzed, and we have to get information out of the data. The matrices, etc., there are different kinds. Now, what we expect from a data scientist? In fact, I also am right now the chairman of our placement committee for a long time now in ISI. So some of the companies approach me asking for, I want a data analyst or a data scientist. So it's very, very difficult to say that we have a data scientist as such, because data scientist, an ideal one, needs good knowledge about the statistical methods, good knowledge on machine learning, and also good programming skill, like something like Python, which is developing very fast now. Now, it's very, very difficult to get a person who has all these things in one person. So in some cases, I told them that you take at least 2 people and try to form a team. Somebody who knows a good amount of statistics, who is quite familiar with that subject, somebody from the computer science group who is very familiar with the other 2. These 2 probably can combine and probably serve you better. So many such companies have listened to me, and then they try to, instead of 1 person, they hire 2 persons and then try to form a team. So that is what my personal understanding is. Data scientist means basically all these things. Now, even if I assume that nowadays the students who are coming up will be having the programming skill, because they have been right from the beginning, they're familiar with the computers. So even if I assume that, the other 2 things, like the statistical knowledge and the machine learning knowledge, is not so forthcoming, right? We need some training on that. So that is why from next slide onwards, I will try to talk about statistical methods and machine learning, how they combine together to solve some of the problems. So, yeah, there's a spelling mistake here, recruitment, it should be spelling mistake. So what a data scientist knows at the time of recruitment. So nowadays, even though most of the posts where even our people are going and people from different colleges are also being taken as a data scientist. So at most 2 subjects from the above 3, probably they can claim that they know. But all the 3, probably that will be very, very rare. Yeah, so the next question is there any course on data science in India? That's a very big question, because the answer is yes, but there is a but. Because I have seen in many cities, because there is a huge demand of data scientists, the program on BSc, MSc kind of program on data science have come up. But they really are not able to cover all the three things. So I know, some institutes from Chennai, obviously I won't name them. From Chennai, the students who come from that institute from a data science course, they know very good programming knowledge is very good, but the other two are missing. There are private people who had come up with different courses. I have seen one in Mumbai. They charge heavily because it's private, but still they don't have really good teachers. They don't engage full-time teachers there. So they try to hire teachers from different places. So obviously the kind of expectation that is required from a data scientist will not be there from many such courses, but still we go for it. Yeah, incidentally, we have a course we have started quite a few years back, but that is also a costly course, I would say. And that course is a diploma course. It's a PG diploma course in business analytics. So there, ISI Calcutta, IIM Calcutta, and IIT Kharagpur, these three institutions together came out with a course which is quite good, obviously. There are some other courses also which I found to be quite good. Some of them are having collaboration with some private organizations, mainly for marketing, but they are giving good courses on data science, and some of them are available on online mode as well. Now I'll come back to the problems that we have faced. So one is, I'll give a couple of maybe 2-3 problems that we have faced so far, where we have used the data analytics to solve that problem. So one is the MBA school. An MBA school in India wanted to know how the placement percentage can be increased from their present level of about 60%. Obviously, as one can understand that MBA schools, because they charge heavily, so if they are not able to place their students, then after some time, it will be difficult for them to run the program. So right at the time when we took up this problem, they were having 60% placement. Now, but they also offered some data. So without data, we cannot solve. So the data available was the profiles of the students who were admitted, along with the knowledge whether the student was placed or not. So for 5 years data they had given, where the admitted student's profile was there, along with that, whether that student was placed or not. So the final column was yes or no type. So with that data, they wanted to find out how or what kind of students they should consider so that their placement percentage can increase. That is one way of looking at it. Obviously, the curriculum changed, this and that, so that's a different thing. So that also can be thought of. But based on this data itself, whether we can say that if you admit this type of students, then probably your placement percentage might go from 60% to about 90% or so. So that was the problem here. This is just the sample data, like obviously the gender is one of them, male, female. Then the percentage obtained by the student in SSC. So these data are for the students who were admitted in that MBA program. So percentage SSC, then SSC board also might be having some effect. Then the board is SSC board, then HSC percentage, HSC board, then the stream in HSC, whether commerce, science, etc. The degree, in the degree course, how much percentage they have obtained, etc. So there are several variables. I have shown only some sample ones. And then finally, the data was something like this, whether the student was placed or not. So either yes or no. Okay, so with this data, you can see here, there are about 24 explanatory variables, out of which 7 are categorical, 10 are continuous variables, and 7 are dummy variables. So this is what a profile of a student looks like. And there are several such students profile, because for 5 years data they had given. Now this is another problem I have got from USA. This is quite some time back in 1998, when probably data analytics was not born. So the company wants to know the target population of a city Y in USA who would probably purchase their product. So the problem was something like this: the profile of the people of different city, say X, where they have actually launched the product, along with the information about who had already purchased the product. So that they know, because in city X, the product was launched and they know who had purchased their product. So based on this data of city X, they want to now go to city Y, another city in USA, where this being the X city being the first city, so probably they have spent a lot of money in marketing, etc. Now, obviously, now they have gathered some experience from city X. They don't want to spend that much of money and time for another city Y. So now they want to know who is the target population on whom they will spend some time and money. Okay, not the whole set of people in city Y. So in city Y, they wanted to find out the target population who would probably like to buy their product. Okay, so that is the problem. So we can see here that the problem that I got from USA and the problem, the MBA school problem, basically, even though it solves different problems, but basically, as far as a statistician is concerned, the problem looks to be same. Okay. So what are the similarities between the two problems? Because both the problems, we would like to know what features are really important for the given problem at hand. So the features, in the first case, the MBA problem, the features of the students are there. And in the second case, the feature of the general public is there. So we have to find out, based on the data, what are the important features. So basically, it's the same problem in both the cases. Now, this is another application of data science or data analytics, whatever we call. A credit card company receives thousands of applications for new cards. Each application contains information about, again, these are the profile of the people who are applying for credit card. Now, the problem is to decide whether an application should be approved or not. So basically, we have to classify the data into either the approved class or not approved class. Now, how do we do that? There should be some logic. So those things should come based on a lot of information that they already have gathered based on their past experiences. So the question is, when in 1998 I got this problem, I was thinking about only solving it using statistical methods. Now, if the problem is given to a computer scientist, probably he would have thought about using computer science knowledge to solve that problem. So you can see here, this is for the first problem, MBA problem. You see this, some of them are statistical methods, some of them are, say CART is a statistical method, ANN is a computer science method, neural trees is a computer science method, entropy nets is a computer science method, SVM is connected with computer science. So random forest. So many things, you see, individually on the same data, if we apply, we'll see that these are some of the things that normally when we apply data analytics, we use this. These are the criteria based on which we decide whether a particular model is good or not. Okay, and obviously accuracy is one of the important criteria. So you can see here that linear discriminant analysis or linear regression, so all KNN, SVM, etc. So individual methods, when it is applied, how they perform as far as the criteria is concerned. Now, if you look at these, the last one, where we have applied, classification tree, CT, with ANN together. So we'll call that as a hybrid method because CT or the classification tree is a statistical technique. ANN is a computer science technique or machine learning technique, I would say. So we have joined these two. And we found that in most of the criteria, that is much better. So you can see here the MBA school data, if I apply this. So this is where I'm talking about data analytics comes. The knowledge of statistics and machine learning together can probably give much better results. Okay, so you can see here that with the help of this hybrid methodology, we are able to get about 91.6% placement. So where that's what their data suggests, that if they select the people based on this model, then they will probably get 91% placement straight away. And obviously, if they try to change the syllabus and do something, probably it can further increase. So this is where we find that a combination of statistical methods and machine learning methods are quite useful. In fact, some of my students have done research on that. So we have developed this method, proved that theoretically that it's not like what computer scientists normally do is apply, they develop an algorithm and run it for 50 sets of data and show that it is working well. So obviously, because in statistics, we try to find out the theory part also, apart from the application. And then we found that theoretically also it becomes quite strong if we combine these two. So that is where we are talking about hybrid models. Now, some of you might be having some doubts about what is a hybrid and an ensemble model. I have given here a reference which gives some idea about, basically ensemble means both the models are homogeneous models. If they are put together, it's called ensemble. But if the models are heterogeneous, like one is from statistics field, one is from machine learning, so the models are really heterogeneous models. When they combine together, that is what is known as a hybrid model. So we have developed some hybrid models for solving this kind of problems. Now, what I have said so far is what is known as a classification problem. Because finally we want to, so when a student is admitted, we want to find out whether he or she is going to be placed or not. So we want to classify as yes, he is going to be placed or he is not going to be placed. So based on that, the decision during the admission itself can be taken. Or if you look at the second problem, so the profile of a person is given in a new city. So based on the data that was obtained earlier, we can say that whether this person is going to purchase the product or not. Okay. But here I have a different problem. Here I have a different problem. So this problem we got from ITC. In fact, we had been working with ITC paper industry for a long time, all their 4 factories all over India. So there are a lot of problems that came, which are quite interesting problems. For some of the problems, we use this hybrid method, but it's not a classification problem, it's a regression type of problem. Why it's a regression type of problem? Because you see, the problem is maximizing the efficiency of the process fiber filler recovery equipment. That is also known as a Crofter supracell. So that is what they want. They had some efficiency, but they wanted to increase the efficiency as usual, obviously, because they have to be in the market, they have to compete. So efficiency of this is a sub process, this is not the main process, this is a sub process, but even there, a lot of fibers and fillers. See, there are a lot of fibers in the paper making industry, huge amount of water is required. And that is why most of the paper mills will be on the bank of a river, so that they can draw a huge amount of water. But it's not all the water is consumed. Most of the water comes out during the process and it is taken back. So in that, waste water, there is a huge amount of fibers and fillers. Fillers are chemicals, very, very costly chemicals. So fibers are, which comes from bamboo and things like that. So that is also very costly. So these things go back along with the wastewater. So they have a system of recovering some of these fibers and fillers using a machine called Crofter supracell. So in that, if they can improve the efficiency of that process to a satisfactory level, then obviously they'll be able to save a lot of important fibers and fillers, and obviously it will be more competitive. Cost will be lower. So that is what the problem they had given, and that we tried to solve it using this one of the hybrid methodology that we have developed. I'm not going into this. This is the actually in the factory, how it looks like. So I'll skip this. So again, you can see here the sample data set, tissue 1 and tissue 2, 2 different tissues we have taken from 2 different machines. And there are different parameters of the process. So again, we have every time all these parameters are logged, because it's a continuous process and the parameters are logged continuously. So it's a huge amount of data. And then finally we know from that process how much amount of what is the efficiency? So efficiency percentage is the final point of interest. So obviously, some of these parameters must be quite important as far as the efficiency is concerned. Okay, so we have to find out, because there are several parameters are there, and it's a continuous process, a huge amount of data are being logged every second. So dealing with this kind of data and then still finding out how the efficiency can be improved, that was the big challenge. So this is just for the participants to know how things have come, data analytics, even though I don't think the scale of the year is really good. But basically, the whole thing started with industrial engineering. There are several different kind of techniques that had become quite famous, quite popular in the world, including ISO. Many of you I know that are not familiar with most of these things. So I just wanted to tell you that the development of data analytics, which I say that it's probably 1998 is the probably the birth year of data analytics, when I got the problem from USA. Before that, there are a lot of other things that has been developed. Some of them have given very good results. Some of them have given good results temporarily, but not in all situations. Like, say, for example, quality circle, etc., that was very popular in Japan. It has given very good results, but in different setup, like in India and many other places, probably did not give that much of results. But definitely Six Sigma and things like that has given results in all types of situations. And the advantage of the development that has come later on is the good things about all these initiatives that had been developed earlier can be taken up, and then we can use it in data analytics. That's the most important part of it. So as I said, that data analytics basically talks about we need a good statistics knowledge along with a good machine learning knowledge. So if you look at the machine learning, for quite some time in the computer science, the computer scientists were independently trying to solve many such problems without looking into the statistics part. So they were developing their own methods. And you can see here 2010 onwards, the whole thing became data driven, because the industry and many organizations, as I showed earlier, you see ERP. So the data collection using ERP, there's a huge amount of data being collected. ERP is implemented in many places. So now, as a statistician, when we started our journey, of course, in fact, I still remember in some of the factories, I stayed overnight to collect data because data as such was not available. Okay, so but then the problem became slightly different. With the help of ERP, now all the data are being collected and stored, but nobody is there to analyze those things. So that is a different kind of problem. So people have to take challenge as the things changes. So now there's a huge amount of data in most of the cases, and then we need to know how to analyze this data. So computer science, they were trying to develop lots of things independently. But then finally, I have seen there's a book written in 2004 called All of Statistics. So there one can find out that many of these machine learning things actually are basically a statistical concept, but then probably solved in using the computer science knowledge. So by 2010, we have got computers very powerful enough. Smart computing sensors are there. huge data are available and efficient algorithms are developed. So we have now a situation where probably we can make use of machine learning and statistics together. And obviously, when I combine two things together, it has the advantage of getting the good of both, and it can try to limit the disadvantages of individual methods. So that's the advantage of hybrid methodology. Well, this is again a history part. I'll skip this. So 2012, there was a breakthrough in computer science, ImageNet classification with deep convolution neural network. So that gave a lot of advantage in solving big data kind of problem. So if you look at the problems that I've already described, and if I, as I said, that data science, assuming that people who are coming up now will have computing knowledge already. So basically they have to learn statistics and machine learning. So these are the two things one is expected to have to be a data scientist. So in that, there are different types of problems that come. One is called the supervised learning type of problem. The supervised learning means the machine has to learn, like we learn from class 1 to class 2 to class 3, etc. We learn different subjects slowly. Now, machine has to learn from data. So that is why, how they learn, like the example of MBA students, I know that if this profile is there, then I know whether he was placed or not. So that information is already available for 5 years students, okay, for 5 batches. So I can make use of the data to develop the model using computer. So that is what is known as supervised learning. Like the regression, so the categorical or the classification problem like MBA problem or the USA problem, as I said, they are classification problems because knowing the profile of a person of a city Y, I have to tell whether he is going to purchase this product or not. So basically it's a classification. There are other problems, like I have shown one problem, the problem 3, which is a regression type of problem. Okay, I have huge data. For every row of that data, I know what is the efficiency. So that is already known. So based on that, I can supervise the learning process of the computer and then try to develop a better model. So both for regression as well as classification, if the data is of that kind, then I can say it's a supervised learning problem. Otherwise, if I do not know, so I only have the profiles of the people and I really do not know whether he or she is going to buy the product, or I have the profile of the students in the MBA program, but I do not know whether he or she has been placed. Suppose the last column is not there. Then whether data can say that which set of people are going to be placed, which set of people are not going to be placed. Yes, data has lots of things. So even if that information is not there, if that information is there, I will go for the right-hand side, which is known as supervised learning method. If that information is not there, then I'll go to the left-hand side, and which is called unsupervised learning method, where we use the standard statistical techniques like clustering, and this reinforcement learning is something being developed in the computer science. So now I think we have a good amount of clarity about what should be considered as a supervised learning, what should be considered as a unsupervised learning. Based on that, we have to use the appropriate methods. So in machine learning, like human beings learn from past experiences, a computer does not have experience, so that experience they will develop based on the data. a computer system learns from data which represents some past experiences of an application domain. So our focus is learn a target function. So based on the data, we'll try to develop a function which is known as a target function that can be used to predict the values of a discrete class attribute. For example, the approved or not approved in the case of credit card applications, or whether it's a high risk or low risk, even in the case of credit card. The task is commonly known as supervised learning, where I can have a classification. So this type of problems are known as classification problems.
Yeah, I'm connected. I'm already.
Yeah. So, so supervised learning, unsupervised learning, I have already explained. These are some of the real life applications of those things. You can see there's a drone here. There are many other things where this can be applied. Here are again several such important applications. Like a machine translation, which is very much required. So here the language spoken in one particular language, the machine should be able to translate into a different language. So lots of things are being done. And one of the recent one of interest is the autonomous vehicles. That is self-driving cars, which are already being tried out. And I think it will take still quite a few years to see that on the road. Now, this is a machine learning application. An emergency room in a hospital measures 17 variables like blood pressure, age, etc. So the moment a patient goes to a hospital for emergency, some of the things are being checked regularly. So a decision is needed whether to put a new patient in an intensive care unit or not. So that should be based on these data. As soon as the patient comes, that data is taken. And based on that data, if the doctor is there, normally experienced doctor, he or she takes a decision. But suppose in the absence of a doctor, if I have this data, can the machine take a decision to the extent possible accurately? Yes, that should be possible, provided we have reliable data here. So based on the expert's knowledge, that can be transformed into a model, and then based on the particular patient parameters, the machine can decide whether he or she should be put in intensive care or not. How much time do I still have?
5 more minutes, sir.
Okay. So fine. So basically, I think I tried to give some explanation about what is supervised kind of problem, what is unsupervised kind of problem. Classification, regression type. Classification is like yes, no type of data. So finally, I have to say whether the person is going or the student is going to be placed or not. So there's a classification type of problem. The regression problem is where the parameter of interest is continuous in nature. Now, there can be several ways of developing the model. You see, if I want to differentiate between two classes, and suppose these points are belonging to one class, the crosses belonging to other class, then a simple line can differentiate both the classes. So that's a simple problem. But the next case, again, this is a different group and the crosses are a different group. But if I want to find out a differentiable function, then that function looks like this one, which is quite difficult to develop. So depending on the problem at hand, things can be quite difficult also, but methods are available by which we can do it. I'm not going into this non-parametrics. Okay, these statistics students obviously will know that, so I can skip that. So this is the, what is the data type? So there are several attributes, several parameters, several features, and then find out a classification model by which I can say that whether a person is going to be placed or not, something like that. So again, the business school data I have discussed here. These are the performance metric of a model. These are, that is for the classification type of problems. These are the, say, AUC, measure, accuracy, etc., precision. These are some of the things that are the criteria based on which we decide whether a model is good or not. For the regression type of problems, we use MAE or RMSE or MAP, and finally, of course, adjusted or R-square or adjusted R-square is the final thing. Okay, so all these parameters can be together can tell us whether a model is good or not. So just a glimpse of what we have done for those type of problems. So we first applied CART, that is classification and regression tree algorithm, to train and build a decision tree and record important features. So decision tree itself will segregate some of the features which are important. So we will take that. Earlier using only statistics probably would have stopped there. But then now we have the machine learning tools as well. So we have taken the important features from CART algorithm along with the prediction by CART. So all the important features plus another feature, which is the prediction from the CART itself. So these, all these are put into ANN. So one hidden layered ANN, that is artificial neural network. So these parameters, which are important parameters known through statistical methods, has been put into the neural network, and then neural network was run. And obviously, this is a decision tree that we have got. So you can see here the HSC percentage. If somebody gets greater than 48, in degree percentage, somebody gets greater than 59. So if we follow this path, the bold arrows, then that will probably give a 90% probability of getting placed. So this is done by a statistical method, but then we wanted to improve that further, and then we used ANN after this, and that improved the accuracy to about 90%.
So time up, so sorry.
Yeah, so this is what I have shown you earlier already. Industrial data set, I will skip. This is a typical neural network where you can see the features that are important features that came out from the statistical method that is given as the input for the neural network, along with the prediction from the statistical method that is also given as an input. So that is called RT. RT output means the regression tree output is considered as a separate input here. And then we ran the neural network to get the percentage recovery. This is the regression problem in ITC. So while doing this, we found that most of the data sets are imbalanced. So we started thinking about how to deal with imbalanced data. We tried to develop some more methods for that. And these are some of the, in fact, Tanujit is my student. We have done some work to develop these methods. Thank you.
Yes, Professor Asim Chakravarti, are you
Yes.
hearing me?
Yes,
Yeah.
please. Yes.
Yes, a wonderful discussion on this area with some examples. But one thing I want to know, specific program, or we place it with the MSc Data Sciences?
Sorry, I'm not able to hear properly. What is the question?
Actually, it's still there. Yeah. Okay. Yeah. Question. General question I have in mind. Is there any need to continue the MSc Statistics program, or we need to change it with the MSc Data Sciences?
Okay. The current, yes. So the current trend is for the data scientists. So if you can at least incorporate some of the machine learning things into the MSc courses, that's fine. So that will be the best thing possible.
Okay, so still we need to continue the MSc Statistics program, but we need to modify the curriculum.
Right.
So, okay, so thank you, Dos.
Yeah, Professor Jayashree, you wanted to say?
Sir.
Yes, please.
Yes, sir. Actually, in the chat box, we received a question from a participant saying that what CT represent in CT-ANN method.
Okay, CT is for classification tree.
Okay. Thank you, sir. Thank you for the nice lecture, sir.
Thank you.
I thank the speaker for joining us today in this particular workshop. Thank you, sir, for your wonderful lecture. Thank you.
Thank you.
Hello, am I audible?
Yes.
Am I audible?
Yeah.
I'm Dr. N.C.H. Bhattacharyalu, Department of Statistics. It is great pleasure to introduce Professor Anuj Chaturvedi, Department of Statistics, University of Allahabad. So, the major research interest areas are regression analysis, panel data, econometrics, seemingly unrelated regression models, the measurement error models, model averaging, decision data mining. He published more than 100 research papers in various national and international journals and edited 2 books published by Marshall Decker and Brown Walker, and also his visiting professor for the various universities in Australia, China, France, Germany, Hong Kong, and Netherlands, Norway, United Arab Emirates, taking assignments, and also visiting later for giving the seminars for various institutions. So I'm inviting you for enlighten the participants. Please welcome, sir.
Hello.
Please unmute.
Yeah. Can I start?
Yes, you can share the screen, sir.
So can you see my screen?
Not yet, sir. So you need to select the PPT there. Share my screen and select the PPT. Yeah, now put it on full screen, sir.
It's okay.
Yes, sir. You can go ahead, sir.
Okay. So first, I would like to thank the organizers of the workshop for giving me this opportunity to interact with the participants of the workshop. The title of my talk is Long Memory Processes in Time Series. Mainly, I will discuss autoregressive, fractionally integrated moving average processes in my talk. Here is the brief outline of my talk. First, I will give the introduction part, then just in brief, I will discuss the autoregressive integrated moving average models. And then I will come to the long memory processes, fractionally integrated noise processes, and then I will come to the fractionally autoregressive, fractionally integrated moving average processes. And finally, some concluding remarks. Now, the classical approach for analyzing a time series is to decompose the time series into 4 components. This is the part which is still we are teaching to undergraduate students in many universities. We decompose the time series into 4 components: secular trend, cyclical component, seasonal component, and then finally we have leftover, which is random or irregular component. So this is the traditional approach for analyzing a time series. The specific feature of time series observations is that the current observation is affected by past observations or past shocks. In usual statistical inference, we assume that different observations are identically independently distributed. But in time series, different observations are autocorrelated. Or you can say the current observation is affected by the past observations, or past observations have information about the current observation. Now, the Box-Jenkins approach utilizes this feature of the time series observations. Since the current observation is correlated with the past observations, or it is affected by the past observations and past shocks. So we can model the current observation in terms of the past observations and past shocks. And in Box-Jenkins approach, basically we use the linear function of past observations and past shocks, as well as the current shock also, to model the current observation. So we write the current observation as a linear function of past observations. We take past shocks, and then we also take in the model the current shock. Now suppose Yt is the time series. Small t belongs to capital T, and capital T is the set of all possible values of small t. Now we consider the moving average process of order 1. Say, in moving average process of order 1, we write Yt equal to mu. Mu is the mean of the process, plus ut minus theta 1, ut minus 1. So basically, the MA1 model process has the current shock on the right-hand side, ut is there. And we also assume that Yt is affected by one period lagged shock, ut minus 1. So this is how we model the current observation. We use the one period lagged past shock. Now suppose B denotes the backward shift operator. So Bj ut is equal to ut minus j. Then we can write Yt equal to mu plus 1 minus theta 1 b ut. You can easily obtain the variance of the process, which is sigma square y equal to sigma square u into 1 plus theta 1 square, and then the auto covariance function. Gamma 1 is equal to minus theta 1 sigma square u. And for k greater than or equal to 2, gamma k is equal to 0. So notice that for MA1 process, all the auto covariances are 0 except the first auto covariance, gamma 1. Gamma 1 is non-zero, and then gamma k is equal to 0 for all k greater than or equal to 2. So you can say that only one period lagged shock is correlated with, or it is going to affect the present observation, and then one period lagged observation is just correlated with the present observation. Yt minus 1 is correlated with Yt. Then you can obtain the autocorrelation function for MA1 process also. Again, it is non-zero for k equal to 1, and it is 0 for all k greater than or equal to 2. Similarly, you can define moving average process of order Q, MAQ process, where you write Yt as a function of ut, ut minus 1, so on ut minus q. So you can say that the current observation is affected by the past shocks up to lag q, ut, ut minus 1, so on ut minus q. Or you can write Yt equal to mu plus theta b ut, where theta b is this operator, 1 minus theta 1 b minus theta 2 b square, so on minus theta q, b to the power q. Now you can easily verify that even for the MAQ process, rho k is equal to 0 for all k greater than or equal to q plus 1. So the current observation is just correlated with the observations Yt minus 1, Yt minus 2, so on Yt minus q. The observations up to lag q. and then it becomes 0. Similarly, for auto-regressive process, suppose we consider AR1 process, then in AR1 process, we write yt equal to phi1, yt minus 1 plus delta plus ut. So this yt depends upon yt minus 1. And then you can write the model in this form also. And then you can easily verify that loop K, the kth autocorrelation coefficient is equal to phi1 to the power k. And here we assume that mod of phi1 is less than 1. And from this expression, you observe that as k increases, the ACF declines exponentially. It declines very fast. For moving average processes, ACF becomes 0 after the certain lag. So you can say that for moving average processes, the memory is up to a finite lag. For auto-regressive processes, although ACF does not become 0, but it declines very fast. On the other hand, if you take phi1 equal to 1, which is the case of unit root, and then we write the process as I1 process, integrated process of order 1. Then you can write yt equal to yt minus 1 plus delta plus ut. And then you substitute yt minus 1 equal to yt minus 2 plus delta plus ut minus 1. So you can write the process in this form. And then we proceed further, and ultimately you get yt equal to y0 plus t times delta plus summation j equal to 0 to t ut minus j. So the effect of all these past shocks remains in the process. Means you keep on increasing the value of j, but this effect of ut minus j remains there in the process. The process is non-stationary in this case, but if you take the first difference, yt minus 1 is equal to delta plus ut, and then it becomes a stationary process. This process has infinite memory. Infinite memory in the sense that any shock has a very long-term effect. It has infinite memory. So for mod phi1 less than 1, the process has short memory because the ACF declines exponentially. The correlation between the autocorrelation rho k vanishes very fast. It declines exponentially. And if you take phi1 equal to 1, then the process has infinite memory. So there is nothing in between. Means either you can model a process which has short memory, or you can model a process which has infinite memory. In general, for the LP process also, the ACF decays exponentially. For example, if you take ACF of this process, then the autocorrelation function, this tends to 0 very fast. Often in many applications, you observe time series which have long memory. So for long memory processes, if your time series has long memory, if any shock or any observation is going to have effect for a long term, then you means your usual ALMA process fails to model such kind of long memory. These ALMA models can capture short-range dependence, but these models cannot capture long-range dependence. And if you can consider the integrated processes, then integrated processes have infinite memory. So still, you cannot capture long memory using an integrated process. The dependence between time series observations decreases rapidly in the ALMA process, and in the integrated process, you get infinite lag memory. And if you take the difference, then it becomes short range dependence. Means after taking the difference, it becomes a stationary ALMA process, so it has a finite memory. Now in integrated processes, for example, here, to make the process stationary, what we have done, we have taken the first difference. So the order of differencing for these processes is an integer. You take the first difference, it becomes a stationary, or you take the second difference, it becomes a stationary. So order of differencing for the processes is an integer. Now suppose the time series has a long-term dependence, so then it is called long memory or long-range persistence. Again, as I mentioned earlier, ALMA processes fail to model the long memory phenomena within the time series because their ACF decreases exponentially. Now you may consider the auto-regressive fractionally integrated moving average processes. These processes are able to capture long memory present in the time space. The reason is ACF of these processes decay much slower than the exponential decay. So this is the reason why it makes these processes a strong candidate for modeling time series having long memory. And then these models provide a much improved fit and better prediction in comparison to ALMA process for time series possessing long memory. So now we consider these processes. So first we consider fractionally integrated noise or auto-regressive fractionally integrated moving average process of order 0D0. Here, this 0 denotes the order of the auto-regressive term. This 0 denotes the order of the moving average term, and this D denotes the order of fractional integration term. Now, in usual integrated processes, this D is an integer. Whereas in fractionally integrated processes, this D is a fraction. It can take value 0.25. It can take value minus 0.25. So it's a fraction. So the process YP is a fractionally integrated noise or fractionally integrated process of order 0D0. So if order of auto-regressive term and moving average term both is 0, then the process is called a fractionally integrated noise. And here we take D lying between minus 0.5 to 0.5. This condition is required to make the process a stationary process. Then we write the process as 1 minus d to the power d yt equal to ut. For d equal to 1, it becomes an integrated process of order 1 or simple random walk model. But here we are taking d as a fraction. So it's a fractionally integrated process. UT is the usual white noise process. It has been 0 and values must value. Now, if t lies between minus 0.5 to 0.5, then you can write 1 minus b to the power minus t in this form. Summation j equal to 0 to infinity psi j b to the power j, where the expression for psi j is this. So this is the stationary solution for the process. Yt equal to summation over j psi j ut minus j. Provided d lies between minus 0.5 to 0.5. So this is the condition which we require for a stationary solution of the process. You can also obtain the spectral density function of the process, which is equal to sigma square u upon 2 pi or 2 sine omega by 2 to the power minus 2d. And for small omega, you can write sine omega by 2 approximately equal to omega by 2, and then your spectral density function is equal to this. And from here, you observe that the spectral density function is finite only when d is less than or equal to 0. You can also obtain, of course, I am not giving you the detailed derivations here, but you can obtain the auto covariance function as well as auto correlation function for these processes. And if we use the Stirling's formula, then for x tending to infinity, you can write gamma x in this form. And then psi j is approximately equal to j to the power minus t minus 1 divided by gamma minus t, and rho k is of this form. So notice that rho k is proportional to k to the power 2d minus 1. Now for d approximately equal to 0.5, of course d is less than 0.5, but if it is very close to 0.5, then rho k decays very slowly. From here, you observe that if you take d very close to 0.5, then rho k decays very slowly. And the process has long memory. And if d is approximately equal to minus 0.5, then rho k decays faster. So from this expression for rho k, you observe that you can use this process for modeling a long memory. So this is the beauty of fractionally integrated processes. These processes successfully model the long memory present in a time series, present in an economic time series. So a long memory process is a stationary process with rho k approximately equal to you have some constant C and K to the power 2D minus 1. Now, if D is less than 0, then if you take summation, K equal to minus infinity to plus infinity mod rho K, then this is finite. And in this case, the process is intermediate memory process. Whereas if D lies between 0 to 0.5, then summation over K mod rho K is infinite, and then you say that the process has a long memory. And then I also defined the anti-persistent time series, and in anti-persistent time series or mean reverting time series, an increase will most likely be followed by a decrease or vice versa. It is just like that. Suppose you have two random variables, X and Y, which are negatively correlated. Then usually an increase in X implies a decrease in Y. So if successive autocorrelations are negative in the time series also, then an increase will most likely be followed by a decrease or vice versa. And then we say that the time series is anti-persistent or it is mean reverting. It is moving towards, means once it goes above the mean, then it again the time series tries to come back towards the mean. So it is mean reverting. Now an index of long range dependence is Hurst exponent. So it is used as a measure of long-term memory of time series. Whenever using any software, you fit a fractionally integrated process, then usually the output also gives you the Hurst exponent. It was actually developed in hydrology for determining optimum dam length for the Nile River. And so suppose YT is your time series, so you have n observations for the time series. Sample mean is YT bar, and this is sample variance. Then mean, we calculate the mean adjusted partial sums. ZT is equal to summation j equal to 1 to t yj minus t times YT bar. And then we calculate the adjusted range, means Rn is equal to maximum of jets and minus minimum of jets. So it's the range. And then rescaled range is defined as Rn upon Sn, where Sn is the standard deviation. And it has been shown that the expected value of Rn upon Sn is proportional to n to the power h. So from here, you can write log of Rn upon Sn equal to, say, alpha plus, you take log of this, h times log n, plus you have some other term. So here you have taken expectation, but here there is no expectation. So we take some other term also. And then you can apply OLS to this equation.
5 more minutes, sir.
Okay. And then you can estimate, just you simply apply the least square procedure, then you can estimate the Hurst coefficient. Again, for long memory structure, h lies between 0.5 to 1. If h is greater than or equal to 1, then the process has infinite variance and it is a non-stationary process. If h lies between 0 and 0.5, then it implies anti-persistent structure, the existence of anti-persistent structure. Means then the process is mean reverting. And for h equal to 0.5, the process is a white noise process. So once you fit a fractionally integrated process, just observe the value of h, and then you can say whether the process is anti-persistent or it is a long memory process, it is a stationary or non-stationary, etc. And basically, this long-range persistence is characterized by, instead of an exponential decaying ACF, here you have hyperbolically decaying ACF. So the ACF decays very slowly for fractionally integrated process. Then spectral density increases without bounds as the frequency tends to inflate. And these scale adjusted range is behaving as a function n to the power h. So these are the three main characteristics. Similarly, we may define auto-regressive fractionally integrated moving average process also. Say you take this fractionally integrated process, and then this fractionally integrated process follows a stationary ARMA process. So this process is called fractionally integrated ARMA or auto-regressive fractionally integrated moving average process of order PDQ. It has auto-regressive term of order P, moving average term of order Q, and then you have this integration term of order D. Again, I am not going into much details. You have the same conditions for the stationarity and invertibility, just like those for ARMA processes. You can also obtain the spectral density function. And then for small omega, the spectral density function is of this form. Again, you can calculate the autocoherence function also. Then again, for t lying between 0 to 0.5, the resulting process is stationary, long memory process. And if t lies between -0.5 to 0, the process has spectral density which vanishes at frequency 0, and it is anti-persistent. So here are some final concluding remarks. The usual ARMA processes have short memory, and the integrated processes have infinite memory. But if we consider fractionally integrated processes, these processes provide you an alternative to model long memory time series. These processes can also model anti-persistent behavior of the time series. And then, of course, I have not discussed here all these procedures, but there are several procedures which are available for estimating the fractional integration parameter D. And once you estimate D, you can use the usual procedures which we apply for estimating ARMA process, for estimating the other coefficients of these procedures. And then computer programs in R and in other softwares are also are available to fit all these processes. Thank you.
Thank you, sir. Thank you, Professor Chaturvedi, for kind acceptance in the short period of notice and enlighten the participants in the long memory process and what are the merits and what are the conditions that are on the parameters. Thank you very much for accepting our invitation and enlightening the participants, sir. Now the next speaker, Professor Somesh Kumar, sir, Department of Mathematics in Institute of Technology, Kharagpur.
Good morning, all of you. It is my great privilege to introduce Professor Somesh Kumar, sir, Department of Mathematics, IIT Kharagpur. Professor Somesh Kumar has research interest in the area of statistical decision theory and inference. He has published more than 100 research papers in the area of statistical decision theory and inference, probability theory, quantum computation, and robotics. He has supervised 11 doctoral and more than 200 master's dissertations. He is associative editor of American Journal of Mathematics and Management Sciences. He has been an editorial board and referee for many national and international journals. He has developed 3 video courses on probability and statistics, statistical inference, and statistical methods for scientists and engineers under the NPTEL project of the Ministry of Human Resource and Development. And these are available through websites of NPTEL and YouTube, etc., and have received millions of views worldwide. He received the Platinum Jubilee Lecture Award for the Indian Science Congress Association in 2016. He is an election panel for faculty positions at various IITs, NITs, universities, and other academic organizations. He is also a member of admission committees, board of studies of many institutes and universities. He has delivered more than 150 invited lectures, talks in various national and international conferences, symposia, and workshops, and also chaired sessions. He has been a resource person for several short-term refresher courses at IIT, Kharagpur, and other institutions. He has visited the University of he has visited the several universities, Middle East Technical University, Ankara, University of Colombo, Sri Lanka, for delivering invited lectures. He has held administrative positions of President Students, Gimekana, Dean Students Affairs, organizing person for joint admission test for MSc, etc. Currently, he has interest in contributions of ancient Indians to mathematics. He regularly teaches the course History of Science and Technology in Ancient India for students in IIT Kharagpur for last 6 semesters. He has delivered expert talks on this topic in international conferences. He was the organizer and chairman of the international webinar Bharat Tirtha, an international webinar on Indiology organized at IIT Kharagpur during 7th to 8th November 2020. Currently, he is advisor to the Center of Excellence in Indian Knowledge System at IIT Kharagpur. So we are welcoming you, sir. Please enlighten the participants, sir. Thank you.
I thank the organizers of this workshop to the Indian Society for Probability and Statistics Conference, especially Professor Reddy and Professor Balakrishna and Professor Malik for giving me an opportunity to give this and share my research with the participants here. Let me share my screen. Okay, so can you see my screen completely?
Yes, sir, we can see you.
Okay. Today I have chosen a topic, tests for the homogeneity of effects against ordered alternatives in completely randomized designs with heterogeneous variances. Now, in the design of experiments, the first design is actually one-way analysis of variance. However, there are certain assumptions for carrying out the analysis of variance in that model. Namely, we assume that the errors are independently and normally distributed with common variance. Secondly, the alternative hypothesis is taken to be the inequality. That means either all the treatment effects are equal in the H0, and in H1 it is not H0. That means at least one inequality among the treatment effects is taken. So there is another type of alternatives, that is we can consider ordering among the treatment effects, which happens in many problems. So we have actually taken up this problem, and let me start with the literature review, and then I will propose two heuristic tests for that. And in order to calculate the critical points, we use a parametric bootstrap approach, and then we do simulations to carry out the size and power studies. We also establish two asymptotic tests based on these two statistics, and then we also establish the accuracy of these bootstrap tests. We have also seen that if there is a departure from normality, then what is the effect on the size and the power of these max t and min t and the asymptotic versions of that. And we finally implement it on certain real data sets that we have taken. So in the traditional one-way ANOVA, we consider testing equality of treatment effects against an alternative hypothesis of at least one inequality with homogeneous error variances. However, in certain situations, it is more sensible to have an alternative hypothesis in which the mean treatment effects have a natural ordering. Such applications arise in dose response trials, environmental studies, agricultural and industrial experiments. So towards the end of my talk, actually, I will give you two real examples where you will see one is from industrial, this one experiment, and another is from environmental studies, where actually we get the natural ordering. One can look at the papers by Bretz, Chen 2000, Shan et al. And Williams, where they have mentioned some such situations where treatment effects may have ordering. So how it is helpful that this additional information, or you can say if the alternative hypothesis is that where you have a natural ordering, then it helps us to design more powerful tests. So there are many studies where ordered alternatives are considered, but they either assume equal variances or unequal, but then they take them to be known. So the situation that we are going to consider has not been considered in full detail in any of the existing literature. So specifically speaking, we consider the basic one-way ANOVA model, that is xij is equal to mu I plus epsilon ij. And we have k groups here, I is equal to 1 to k. And from each of the groups, we have n1, n2, nk observations. So j is equal to 1 to ni. So we assume that epsilon ij's are independently and normally distributed, but it is not normal 0 sigma square. We put normal 0 sigma square. That means the ith group has the variance sigma I square. And in general, we are assuming that the sigma I squares are unknown as well as unequal. And we are testing the null hypothesis of equality of the mean treatment effects against H1, which is of ordering, that is mu1 less than or equal to mu2 less than or equal to mu k, with at least one strict inequality. So here mu I denotes the ith treatment effect. Let me just give a brief review of the work that has been done earlier. So Bartholomew 1959, they have derived the likelihood ratio test for testing H0 against H1 when variances are known. Sharrock in 1967 has extended Bartholomew test to one-way ANOVA and general linear models, and also presented a rank analog of them. Williams in 1971 developed a test for testing this ordering, that is m0 less than or equal to m1 less than or equal to mk, with at least one strict inequality, which uses maximum likelihood estimators of the mean responses of k treatment means. And they also consider one control, that is m0. They have taken equal but unknown variances and equal treatment replications. That means this is balanced design that they have considered. Williams in 1972, actually he modified this to unequal treatment replications. That means you have ni's there. That is unbalanced numbers. And then there is a study by Marcos in 1976. He did the power comparison of these tests, that is the Bartholomew's test, Williams test, and he calculated the exact powers for k equal to 3. And for k equal to 4, 6, and 8, he simulated these power functions. In 1989, Mudholkar and McDermott, they have proposed a class of tests by combining p-values for testing equality of treatment effects against different types of order restricted hypotheses. They considered again equal as well as the known variance. And then Shirley in 1997, he proposed a non-parametric version of Williams test. So Williams test I just now mentioned. In one case, they have considered equal sample sizes, and in next one, they have considered unequal sample sizes. So the versions of this one were considered by Shirley in 1997. Then in 2006, Bretz has extended Williams test for general linear models, which allows for the covariates as well as the factorial treatments. Then Cabello and Peng in 2008, they extended Zonkiri's 1954 test for testing equality of the treatment effects against ordered alternatives in a randomized block experiment with incomplete blocks. However, here the variances are taken to be homogeneous. So in all the studies that we have found that error variances are either equal or unequal but known. So there is a typing error here, known here. But the homogeneous variances or known variance condition is not useful in practical situations. And one can look at the examples considered by Bishop and Ludwig in 1978 and 1981. There are papers by Chen in 2000, 2001. And then there is a recent paper by Noguchi in 2021 and Pauli et al. In 2015 and 2016. So Bishop and Ludwig actually, they proposed a one-stage as well as a two-stage procedure for one-way and two-way ANOVA models. And then there have been extension to this by them in 1981 to a R-way ANOVA model. Hassler actually proposed multiple contrast tests using multiple degrees of freedom and sandwich estimation procedure for testing equality of means in heteroscedastic ANOVA. Then Chen in 2000 proposed one-stage and two-stage procedures for testing H0 against natural alternatives in one-way ANOVA with unequal and unknown variances. Harbrich et al., they proposed a test based on multiple comparison procedures for testing equality of treatment effects in heteroscedastic one-way ANOVA model with unequal sample sizes. So all these studies, they consider the estimation condition of heteroscedastic variance. They consider testing against the natural alternative mu i's to be not all equal. However, if we consider ordering, then things become different. Then Krishnamurthy et al. In 2006, they have proposed a parametric bootstrap test for fixed effects one-way ANOVA with heteroscedastic error variances. And they have compared the test with the existing test, that is the Welch test, James test, generalized F test, etc. From their simulation studies, it is observed that the parametric bootstrap test performs better than the others. They also noted that the proposed test is also applicable in random effects one-way ANOVA model with heteroscedastic variances. Then Zhang in 2015, they have considered multiple comparison procedures, that is mu I is equal to mu j against mu I not equal to mu j. And they also proposed a parametric bootstrap, modifying the Tukey's well-known range test. So now we will consider, so what we have done, we have taken the ideas of the parametric bootstrap and considered the most general setup and tried to see what happens. Surprisingly, the test procedure using the parametric bootstrap performs very well. So that is what we have shown here. So let me again specify the model. The null hypothesis is the equality of the mean treatment effects against the ordered alternatives with at least one inequality. And we are considering in general unequal number of replications, that is N1, N2, Nk. So we will propose two tests called max-t and min-t test. We also derive the asymptotic distribution of these test statistics under the null hypothesis. Since we are able to derive the asymptotic distribution of this max-t and min-t, like for the likelihood ratio, if we consider the asymptotic thing, then by Wilks theorem, generally we have a chi-square test. Similarly, here also we are able to get an asymptotic distribution, which is of course based on the multivariate normal. We are able to do another parametric bootstrap for asymptotic max-t as well as asymptotic min-t test. So then we will compare the performance of all of these. So we define the statistic Ti. So if I consider xi bar and si square to be the sample mean and the sample variance for the ith group, then we consider the statistic which is similar to the Welch-Satterwhite statistic, that is xi plus 1 bar. Of course, that one is a more general because that they consider xi bar minus xj bar divided by the respective variance things. But here we are considering based on the pairwise, that means the consecutive differences. So this is the difference from the Welch-Satterwhite statistic here. So we are taking Ti to be this one. Now we define two statistics. One is max and one is min. Of course, there are different logics for both of them. For min T, there is a logic that if there is a strict inequality all through, then the min T should perform better. And if there are some equalities, then max T should perform better. So we considered both the versions, and finally, when we do the analysis, we actually find that. So let me present that thing. So the parametric bootstrap means we generate samples or the sample statistics from parametric models using estimators of the parameters in place of the original parameters. So since the distributions of Tm and Tn under H0, we cannot find the exact distribution. We are only able to find the asymptotic. So therefore, to evaluate the critical value, we use a parametric bootstrap approach. Again, another thing that we can note here, in the definition 4.1, the statistic Ti, if you consider, this is xi plus 1 dot bar minus xi dot bar. So under H0, the distribution will be free from mu. If I take mu1 is equal to mu2 is equal to mu k is equal to some mu, then this will be free from that because the successive differences are considered. Therefore, without loss of generality, when we consider the null distribution, we can take mu to be 0. So when we consider the bootstrap sample from a given sample which has been taken from normal mu sigma I square, we generate the bootstrap sample as xij star from normal 0 si square. So that is the difference here now. Without loss of generality, the mean part we can take to be 0. Otherwise, we have to take xi bar there, but that we have not taken. This is some sort of simplification you can consider here. So when we consider this bootstrap sample, that is xij star from this one, based on that we define the bootstrap version of the Ti. So Ti star, now that is xi plus 1 dot bar star minus xi star bar divided by the corresponding si plus 1 star square by ni plus 1 plus si star square by ni, square root of this thing. And this is of course for I is equal to 1 to k minus 1. And here xi star bar and si square, they are the sample mean and the sample variances of the bootstrap sample taken. So based on this, we define the bootstrap versions of Tm and Tn as Tm star as well as Tn star. That is the max and min of this T, where T is actually T1 star, T2 star, Tk minus 1 star. So the H0 is rejected at level alpha if Tm is greater than D star or Tn is greater than E star, where the critical values D star and E star can be found from the size conditions. So suppose we are taking alpha as the level there. So we propose the following algorithm to calculate D star and E star. So from a given independent normally distributed heteroscedastic sample xij, that is j is equal to 1 to ni and I is equal to 1 to k, calculate the sample variances si squares for all of them. Now generate the bootstrap samples xij star from normal 0 si square for j is equal to 1 to ni and I is equal to 1 to k. Now calculate the values of Ti star for I is equal to 1 to k minus 1 as defined in equation 5.1. That is given on the top of this sheet here. Now, next we calculate the values of Tm star and Tn star as defined in the equation number 5.2 and 5.3. That is the maximum and minimum of these statistics T1, T2 star, Tk minus 1 star. Now we repeat this steps 2 and 3 a large number of times. So we have taken for our purpose 5,000 times. That is the bootstrap sample size every time we are taking to be 5,000. And we rearrange this H values of Tm star and Tn star in increasing order. So that is Tm1 star less than or equal to Tm2 star and so on. Suppose we have generated H times. Similarly, we order the values of the Tn star also in the same way. And we take 1 minus alpha hat quantile as the bootstrap critical value. Because what was the rejection region on the greater side? That is Tm star greater than D star, the probability should be equal to alpha. And similarly, probability of Tn star greater than E star should be equal to alpha. See, in the bootstrap sample, the value of sigma is fixed. And since this is free from mu, so this will be exactly achieved. We don't have to take supremum over sigma I because this is the bootstrap method. It is the inner part, inner, you can say, generation of the samples. So you can see here that we consider D star to be the 1 minus alpha hat quantile from this thing, and E star to be 1 minus alpha hat quantile of this Tn star values. So, so then this D star and E star give you the critical value for a given sample. So when we do the real practical thing, that means we have a data set. Then by applying this procedure, we have actually developed our package for this. We can actually get the critical point and then say that whether we have to accept or reject the null hypothesis. Now let us talk about the distribution theory here. So we will consider the sample sizes to increase to infinity. That means minimum Ni tends to infinity. So we consider that if I define capital N to be the total sample size, then we take the ratios, that is Ni by N, to be some fixed ratio. That means they will converge to some Ri's. So now we rewrite this Ti statistic as root Ni into Ni plus 1 by N, Xi plus 1 dot bar minus Xi bar. So we have done some sort of adjustment of the terms. So the numerator term I am calling to be Zi, and the denominator term I am calling to be Bi head. Okay, because Bi head can be considered to be an estimator of Bi, that is square root Ri sigma I plus 1 square plus Ri plus 1 sigma I square. Now the you know the law of large numbers, that is the weak law of large numbers. So Si square will converge to sigma I square in probability. So this Bi head, it will converge to Bi in probability. So now let us look at what is the distribution of this Zi statistics, that is normal 0 Bi square. Okay. Now we also look at the covariance, because this Zi terms, they are not independent, because like if I consider T1, then it will have a term x2 bar minus x1 bar, then T2 term will have x3 bar minus x2 bar. So they will not be independent. So we have a covariance term also. So covariance of Zi plus 1 converges to minus square root Ri plus 2 sigma I plus 1 square. This convergence in probability. So I call it Ei, say. And when the null hypothesis is true, then this asymptotic setup that we have given here, that means Ni by N goes to Ri as minimum of Ni tends to infinity and capital N tends to infinity. Then under this setup, the asymptotic distribution of Z1, Z2, Zk minus 1, it becomes normal, multivariate normal distribution of the dimension k minus 1 with mean vector 0 and covariance matrix sigma Z. And this sigma Z is actually a sparse matrix where you have diagonal terms as B1 square, B2 square, B3 square, etc. Where Bi are defined like this. That is, Bi square is Ri sigma I plus 1 square plus Ri plus 1 sigma I square. And Ei terms I have just now written here. So the off diagonal term, that means below the diagonal and above the diagonal, I will get E1, E2, and so on up to Ek minus 2. Now I define this B head to be the diagonal matrix consisting of this B1 head, B2 head, Bk minus 1 head. And the corresponding estimated terms are, that is B, that is diagonal of B1, B2, Bk minus 1. Then P hat converges to B in probability. Therefore, when H naught holds true by multivariate Slutsky's theorem and continuous mapping theorem, T will have an asymptotic normal, multivariate normal distribution with mean 0 and covariance matrix D of dimension k minus 1, where D is B inverse sigma Z B inverse. So we are able to get the asymptotic distribution of T. Now this min T and max T are nothing but the maximum values of that vector T1, T2, Tk minus 1 and minimum value of the vector T1, T2, Tk minus 1. So that means if the asymptotic distribution of T is known, that means the asymptotic distribution of the minimum and the maximum is also known. Of course, it is a very complicated distribution because this is multivariate normal thing, and then you are looking at the max of the observations or the min of the observations. So although you may write a theoretical form of it, but doing any calculations out of it to calculate the critical values is going to be very, very complicated. However, we can consider the critical values F star and G star based on the asymptotic version of these two. So I call them to be A max T and A min T. Now look at the algorithm. So in the algorithm, see earlier time, so we initially generate the Xij samples for a given parametric configuration, and then we consider this matrix sigma Z, which I have defined just now, and from there sigma Z head is calculated, where in place of sigma 1 square, sigma 2 square, sigma k square, we substitute S1 square, S2 square, Sk square. That means in the matrix, the sigma Z, we are putting sigma Z head, because in all the places where this term sigma I square is coming, we just put the estimate of that. So that means here this one and here this one. So here we will replace that. That gives us sigma Z head. Now we can calculate this D head, and then we generate from this k dimensional multivariate normal distribution 0 D head the samples of the statistics Tn that we are calling. So we call it Ta star. Okay. Now the estimated test statistic values will be the max of this and min of this. So this is the asymptotic version, you can say asymptotic parametric version of this test. And once again, in order to calculate the critical values, we consider a parametric bootstrap procedure. So we generate a bootstrap sample of size say 5,000, and we have this h number of these values of asymptotic T max and asymptotic T min, and we arrange them in the order, and we consider 1 minus alpha hat quantile as the critical value, that is denoted by F star and G star. So we will show that the asymptotic distribution of the parametric bootstrap statistic T star is the same as the asymptotic null distribution of T, which is nk minus 1 0 D. So we also prove that the difference of the conditional distribution function of T star and the null distribution function of T converges to 0 in probability. So these are required because we should establish the validity of the bootstrap procedure. Although numerically we have actually done it and it is turning out to be that. So the first theorem is that the asymptotic distribution of T star given X. So given a original sample, we generate the bootstrap statistic. The asymptotic distribution of that can also be found to be multivariate normal with mean vector 0 and the covariance matrix D. So in order to prove that, let us look at the bootstrap version of the statistics that we have considered. So Zi star is the bootstrap version of Zi. Then this Bi star squares, they are the bootstrap versions of the Bi heads. And then we can easily see that the expected value of Zi star is 0, variance of Zi star is Bi head square. And this is star denotes here, this in all the expressions I have put a star here. It means these are the conditional given the original sample. Okay. So covariance term is also similarly obtained. Now, given the observations, the conditional distribution of Z star will become multivariate normal with mean vector 0 and the covariance matrix sigma Z square, Z star, where sigma z head star contains the estimated variance terms here. That sigma I square is replaced by SI plus 1 square. Now the asymptotic setup shows that sigma z head star, it should converge to sigma z in probability, because SI squares converge to sigma I square. So similarly, if I consider B star as the diagonal of B1 head star, B2 head star, Bk minus 1 star, so then SI star square converging to sigma I square, it implies that B star converges to B in probability as minimum Ni tend to infinity and N tends to infinity, as well as the Ni by N tends to Ri's. Therefore, if we use these relations and the multivariate Slutsky's theorem and the continuous mapping theorem, we get the result that the asymptotic distribution here of T star given X is multivariate normal with mean vector 0 and covariance matrix D. Now next is we show the equivalence of the conditional distribution of the bootstrap statistic with the original statistic. So this is stated in the following theorem. If I consider the Ft star given X T to denote the conditional distribution of T star given the observations X, and Ft given H naught, if this denotes the null distribution of T, then under the asymptotic setup 6.1, the maximum difference, that is the Kolmogorov Smirnov distance, this goes to 0 in probability. In order to prove that, let us consider this under H naught, we define the statistic root n x1 bar, root n x2 bar, and root n xk bar. So U is this vector. It follows normal 0 sigma k, and X given X, the similar bootstrap version of U that we call U star, that will have multivariate normal with mean 0 and variance matrix sigma 2, where sigma 1 is the diagonal of n by n1 sigma 1 square, n by n2 sigma 2 square, n by nk sigma k square. And in sigma 2, in place of sigma 1 square, sigma 2 square, sigma square, we are having s1 square, s2 square, sk square. So we, in order to prove the equivalence of the results of the distributions, we use a Kullback-Leibler divergence measure. So if we consider the Kullback-Leibler divergence between U star and U, then the formula gives you half. Actually, the general formula is here a trace of sigma inverse, sigma 1 inverse into sigma 2 minus k plus sigma log of determinant of sigma 2 by sigma 1. So since these are diagonal matrices, the things turn out to be extremely simple. The trace becomes this one and the determinants are simply the product. So log of that becomes sum of the logs. So now if I take the limit as Ni tends to infinity, capital N tends to infinity, then Si square converges to sigma I square. So this goes to k. So k minus k becomes 0. And here you get Si square goes to sigma I square. So log of 1 is 0. So this entire term converges to 0 in probability. Now I consider a linear transformation of these x1 bar, x2 bar, etc. That is the U as AU. I call it Y, where A is, so first row is -1, then 1, 0, 0, and so on. 0, -1, 1, and so on. So naturally, Yi is nothing but root n xi plus 1 dot bar minus xi dot bar. So now if we consider y star is equal to y1 star, y2 star, yk minus 1 star transpose, that is equal to au star. So this is the bootstrap version of y. Then from this relation, we can conclude that the Kullback-Leibler divergence between the distributions of y star and y will also go to 0 in probability as minimum of Ni tends to infinity. And therefore, this implies that the Kolmogorov-Smirnov distance between the distributions also goes to 0 in probability. Now I consider T as R head Y and T star as R head star Y star. Okay, so that is our T statistic that we have considered, max T and min T that we are defining from this one. Then it turns out that T is again a transformation from Y and T star is another transformation from Y star. So R head here is taken to be the diagonal of square root N1 N2 by N by into 1 by V1 head. Okay, yeah. Similarly, R head star is the bootstrap version of that. Now, under the limiting conditions, R head converges to R in probability and R head star converges to R in probability, where R is the diagonal consisting of this one. So if again we use the multivariate Slutsky's theorem and the equation 7.4, we get that the theorem's statement holds true. That is this Kolmogorov-Smirnov distance between the distribution, conditional distribution of the bootstrap statistic given the original sample and the null distribution of T, they will be asymptotically the same. So this establishes the asymptotic accuracy of the T star. And now min T and max T are nothing but the continuous functions of T. Therefore, by continuous mapping theorem, we can also conclude that this distance and this distance function goes to 0. Then we have carried out the size and the power studies. Since time is less, I will just briefly talk about the outcomes here. We have considered K is equal to 3, 4, and 5. We considered various sample sizes. We considered various configurations of the variances. And for the power studies, we considered various configurations of mu1, mu2, mu3 in the increasing order. And so many type of possibilities we have considered. And few of the tables we have presented here, you can see here that in almost all the cases, the size 0.05, that is the nominal level that we have considered, that has been achieved, except that A max T is somewhat more liberal. It is actually getting somewhat higher value. You can note here A max T, whereas max T, min T, and A min T are almost accurate. A max T is little bit more liberal because it is getting higher power than 0.05 nominal level. So we have carried out for various configurations. I am not going to show these things. Then we also calculated the powers here, and the power functions you can note here that as the C is the difference here. So 1, 1, 1.5 and so on. So as the C value increases, that means the difference between mu1, mu2, mu3, etc. increases. And you can see here that the power quickly achieves 1. So the power becomes good here. So let me just say these few remarks here. So it can be noticed that the parametric bootstrap based max T, min T, A min T achieve a size of 0.05 for all combinations of the sample sizes and variances which are considered here. In fact, the max T and min T achieve size for a very small sample also, but of course we have not tabulated it here. However, the asymptotic max T test is somewhat liberal for small sample sizes. But if the sample size increases, the A max T also has a size closer to 0.05. Okay, we observe that the powers of all the tests increase as the value of C increases. That means the tests are good discriminators between group means. I think I will just show the example here because there is lack of time. Probably that would be more beneficial. We have done a robustness studies and we have actually shown that the tests are robust. We have implemented on the T test on a T distribution, Laplace, that is the double exponential distribution, and the Weibull distribution also. And we have observed that the test functions are quite robust here. So on the departure from normality also they perform well. Yeah, so we have considered two examples. One, we have considered the signal strength of operators, Airtel, Vodafone Idea, Cell1 and Jio. In October 2021, we have considered the data from different locations of India. So actually it is available on the open government data platform, that is government.in. So original data set consists of 1,50,561 Airtel operators, 96,875 Vodafone Idea operators, 6,787 Cell1 operators, and 3,27,540 Jio operators. From there, we have taken random samples of size 55, 48, 50, and 50 respectively. And based on that, we carried out the thing. Goodness of fit test shows that each of them is normally distributed. And we got the p values to be very this one. That means it is saying that the test is valid. Then we also checked the Bartlett's test, and we found that the variances are heteroscedastic. And from here, we observed that the max T and min T that we have considered here, we found that the min T and max T, they do not, A min T, they do not reject, whereas max T and A max T rejects it. So that is a greater discriminator in this particular case. Then we have considered another situation where we considered air quality index data, and here the results are that both all the 4 tests they reject. This test is also taken from the open government data platform. Okay, so I think probably I have exhausted my time. Let me stop here. Thank you.
We are grateful to you, sir, for your kind acceptance in short period of notice and enlighten the participant. Thank you so much, sir.
Okay, thank you. Thank you. Yeah.
No.
Good afternoon, all. I am Swarnalata. Now I am inviting Professor Rabinarai Subhuti. He is the Senior Professor of Management, Kalinga Institute of Industrial Technology, University Bhubaneswar, Odisha. Sir has published or edited 10 books and over 75 research papers. He writes popular articles for regional newspapers regularly. Sir was the former editor of journal and magazines like Strategy Management Research Journal of Berhampur University. Sir is the chief editor of peer-reviewed management research journal Parikalpana, and also 10 research scholars have already got PhD under his supervision. Sir has presented research papers in over 60 conferences, including 25 international conferences in several countries like USA, UK, Australia, Singapore, Nepal, Bhutan, and India. Sir was the former president of Operational Research Society of India. Sir's major research projects on manpower and employment planning for Government of Odisha, conducted by MBA Department of Berhampur, Odisha University, and the second major research project funded by ICSDS Government of India on digital diversity and internet consumption pattern, and the third major research project funded by ICSDS Government of India on sexual abuses and POCSO, a study in 3 eastern states of India, and the third major research project on funded by GCRF UKRA UK, nitrogen fertilizers uses, future alternatives, and study on impact on social and ecological aspect, a multi-country, multi-institutional long-term. So we are welcoming you, sir. Thank you, sir.
Thank you, Madam Professor Jayasri. Good morning, all revered colleagues, participants. Today, I'll be just presenting one of my work, which will be published by Springer very shortly. It's in press. While thanking Professor Jayasri for very elaborate introduction of mine, let me just add half a sentence that though I'm a student of statistics, I'm into teaching in management department. So all my work is mostly applied to management and decision sciences. And as the theme for today's meet is on social data, development data, data science. So I thought I should present something about handling large data, measuring, identifying, interpreting social development, and particularly in Indian context. I have taken a case study of my state, Odisha. I'll be briefly presenting, and I request the coordinator to stop me if I'm overshooting my time. I hope I should complete within 30-35 minutes, then we can have some discussion, if any. So I would like to introduce that what about development? We started today development. Mostly in science and technology, I personally believe it is perhaps skewed towards profit, or the interest is how to maximize gain. And to me, any development or any economic growth is perhaps not a development if it is not inclusive, if it is not taking into confidence all sections of the society, including the bottom of the pyramid. This present paper, which is a secondary data analysis based paper, looks at different social development models used today globally and analyzes social development data in Indian context. This paper first remembers the great Indian statistical contributor, Professor Mahalanobis. His contribution, which is popularly known as disc statistics, and this paper discusses issues relating to social related large data, which I can say big data, as available from secondary sources published by various agencies. And we'll be focusing on different models measuring social well-being. This is the focus. And when we are talking of social large databases or social big data, we consider social development, social acceptance as researchable constructs. In research methodology terminology, we take it as a construct which is quantified and measured through some operational indicators or variables, and it has been differently measured by different scholars. But the commonality among all such measures, they use large amount of socioeconomic demographic data. That's how the present paper's background, and we'll be calling it as a social big data. I'll be just giving some example, real life contemporary example of social data, large data where we are handling. One such example could be very current, the COVID vaccination data. As you all know, we have vaccinated over 175 crore. When I'm talking about a huge database, who was taken, when taken, at what place taken, who had given, administered the vaccine, everything. The PSC or the hospital, location, everything, all minute detail is given in different columns of that large database. So from that, we can also have some inference analysis, which age group, which demographic cohort or subgroup they have been most vaccinated, and who are the hesitants, and if we have missed anybody, any section. So that can be analyzed using a large database like COVID vaccination data. One more example, which I am referring for my paper, is SDI, Human Development Index. Human Development Index has been calculated since decades by different scholars, by using different parameter, by using different formula. And let's recall the great statesman, P.C. Mahalanobis, and his contribution, which was given in the year 1936. And he was thinking, are all tribes, are all human beings equally into the mainstream? Are you getting the benefit of the social development or not? Because he was the advisor of first Prime Minister Pandit Jawaharlal Nehru. So he wanted to know particularly the tribes or the tribal, how far, how distant they are from the mainstream humanity. So that was something like a vector distance, and will not be going into details how it was calculated, but will be briefly telling that it has been applied for a multivariate outlier detection. Outlier could be either side, two extremes, higher side, lower side, and using social data sets for subsequent classification. Classification means underdeveloped, developed, and the like. And just to introduce a very basic concept, if it is a distance, so if it is two-dimensional, and the distance between 2 points is measured like this, and this can be extended, and the formula was like this. Will not be going into details because our focus is on the case study which I'm going to present just now. Now, for my data analysis, I was searching for government sources from where I can get vital statistics, and these are the popular websites from where researchers, scholars like us usually get, and particularly the focus of this present study is on the social support system and regional safety. How is the governance? Suppose we are voting time and again different governments, how safe we are? Do we really have a support system? Suppose we are in trouble, so how quickly, how effectively we are getting the support of the system of the government? So this is what I wanted to study. That was my main focus of my particular study. And I have taken data for all the 30 districts of my state, Odisha. As the figures statistics show, prior to 3-4 years back, the number of households in Odisha was almost close to 1 crore. It was almost like 97 lakh 4 years back. Now, if we minutely observe each and every household, and can you not measure their well-being, their safety, how they are taken care by the system or the government, how it is possible to understand the safety, security of citizens. So this was studied by taking data from all districts of Odisha, and I wanted to rank what are the districts which are doing good, particularly the district magistrates, collectors should be encouraged, awarded, incentivized, and maybe the districts which are laggards, those who are not doing, should be pointed out by researchers like us, where they are lacking, why they are not doing properly. So I think the research has got many important socially relevant implications. Now, for this, my main source of data was NCRB, National Crime Research Bureau, and I referred the details of the report published in September 2021, and that report was for 2020, but it was released at the end of the month, September 2021. So it's a very latest data, and this is a government authentic data. So this is the data. So I collected secondary data for 30 districts of my state, Odisha. And let me show you the data of what I really selected. Mostly I referred to 6 parameters, just for simplicity, brevity of the research, what I'm discussing today. The total crime happening against backward caste, that is SC/ST, total crime happening against women, total crime happening against children, and the sex ratio of that region, if it has anything to do with the crime, and the, of course, population density of that district and literacy rate. And the data which I got from secondary source is like this on those 6 parameters for all districts. Now, this is something interesting. There's a very simple analysis, as you may please note it down. I just wanted to have a bivariate study if it is giving us any indicative or interesting result. I have highlighted in red few cases. See, the first line is crime against women and literacy. It's shocking that even the literate people in that area is a positive correlation. And the second line, of course, is obvious. More the people, more number of crime that can happen. But the third one, it is, I think, noteworthy. We should all note that if sex ratio is good, crime is less. Sex ratio is bad, crime is more. That means more involvement of women. If more are women, more in number that for women, less is the crime. So this is what is found. This is, I think it's interesting. And the next one is literacy versus the crime. What I can see, even the literacy is shockingly not reducing the crime rate or the crime totality. And the last one I would say, same thing. The crime against the tribal population and the sex ratio is a negative. So it's really a very interesting find for the planners that sex ratio is something we should be trying to increase or have a good balance. And next, for my index, I have taken a very simple formula. I was like calculating the total crimes against women, against child, against the backward caste, and the ratio to the total population density, and what is the average crime happening in that particular district. So now, based on that, so the ratio, if it is 1, it is a balanced one. So as you can see, out of 30 districts, I could find, based on the secondary data, based on the crime report of Government of India. So I could, out of the 30 districts of Odisha, these are the laggards. These districts of Odisha, they are really doing very, very bad. Higher the number, it is still worse. So closer to 1, it is something like not bad, not good kind of thing. And similarly, I could identify these are the districts that are doing really better. And it is less. Okay. So this is what a very simple analysis of my index, what I have developed, and it is being published. And other remaining districts, not so bad. And so where the chief minister or the secretary need to focus on these districts. So I thought this will be very informative for the planners, administrators, and the government if we researchers, scholars do some analysis of socio-demographic data like this. And there is a conceptual model. I'll be ending after 2 minutes. My presentation today will be very short. So we can also, as I started today, we can also measure, quantify, even for every family of a state. Say, for example, a smaller state like Odisha, we have got close to 1 crore families. And we can have a grouping. We can have a like those who are suffering, those who need more attention, those who are well off. And when you are measuring wellness, and maybe like we can have demographic data, demographic parameter, and their physical health, mental health, and sustenance, minimum financial status, what they have. Say, for example, do they have basic amenities like electricity, net connectivity? Are they insured? Do they have savings like this? And we can also go into details like, is it anything to do with their profession? Is it anything to do with their religion? Is it anything to do with their caste or education level? And we should also take into consideration the food basket or the nutrition supplement aspect like this. So these are like the suggestive conceptual model. Now I'll be ending with a posture for all the scholars, those who are listening to me perhaps. Now we, the scholars, professors into data analytics or statistics have got greater role and a greater contribution for social data and more particularly the crimes happening in society. This particular example exhibit is on the 9/11 terrorist attack which happened in US, when they were all shocked that Twin Tower terrorists could demolish, and very soon their scientific team, they could track down the telephone calls of the terror networks. Now this is the voice call tracking. Now why I'm showing this, it's not only the numbers, not only the quantitative figures, we can also have to filter, analyze the qualitative data also, particularly say voice. Say, for example, one person talking to another person for 30 minutes, 40 minutes. So how to record huge data? Say, for example, thousands, millions of people, they are conferring, they are chit-chatting, or they are sending voice messages, how to track them. So that is a challenge for qualitative data analysis for the researcher. I think my presentation is all about this social data. I deliberately wanted to make it brief because it's already lunchtime. So I thought I should not keep you waiting. This is all about my publication. And very soon, within a month, it will be published by Springer. And some related articles is getting published as an edited book. I should be in a position to circulate the published article to the organization. Over to Jayashree Ma. Thank you so much.
We are thankful to you, sir, for your wonderful lecture. Thank you, sir. Let us meet again at 2 o'clock for next lecture or session after the lunch break. Thank you. Welcome back after lunch break. Sir, shall I start? Krishna Reddy, sir. Hello.
Yes, I am available. I'm
Thank
ready.
you, sir. Thank you, sir. Myself, Ranjita. It's a great privilege to introduce you, Professor of Statistics at the CVR Engineering College, Hyderabad, and sir is a retired professor from the Department of Statistics, University College of Science, OU. Professor Krishna Reddy, sir, guided 15 PhD students and 10 MPhil and about 25 MBA projects from IGNOU. Recently, 3 PhD students submitted their thesis in statistics at Usmania University. Sir published more than 50 research papers in the reputed journals. Sir also served as an head Department of Statistics and the chairman Board of the Studies at Usmania University. Sir's major research areas are the time series, neural networks, and forecasting. Sir is also a selection committee member at the state and the national level recruitments. Thank you, sir, for accepting our invitation.
Can I start?
Yes, sir. Thank you.
First, I will share my PPT.
Please make it full screen mode.
Is it visible?
Yes, sir, it is visible. You can go ahead.
And is my voice audible?
Yes, sir, it is audible. We can hear you.
First of all, I want to express my thanks to Professor P. Rajshekhar Reddy, Honorary President of ISPS, Dr. N.C.H. Bhattacharya, Head Department of Statistics, OU, Professor G. Jayasri, Convener, ICSDS 2021 workshop, for inviting me to deliver a lecture in this workshop. And I choose a brief review of time series forecasting models covering from classical to latest deep learning models. Okay, here statistical modeling or simply just modeling. Modeling means we want to establish a mathematical relationship between dependent variable y and independent variables x1, x2, xp. So most of the data analytics problems uses one dependent variable and one or more than one independent variables. Now the data we collect on this y, x1, x2, xp are broadly divided into two types. One is, the first is cross-sectional data. Data collected at a single point in time. Single point means, let us assume it is the data collected at 2 p.m. today. On y, dependent variable x1, x2, xp. If data is collected at a single point, we call it as cross-sectional data. In cross-sectional data, mostly we use the regression analysis for estimating the value of y for a given values of x1, x2, x. In case of cross-sectional data, estimating y for a given values of x1, x2, xn, we call it as predicted values or predictions. The second type of data is longitudinal data. Data collected at different time points. If you are collecting data on different time points, maybe on single variable or on y and x1, x2, xp, such data we call it as time series. But in time series, estimating the future values, we call it as forecast. Okay, if data is cross-sectional, and if you are using regression analysis, the estimates of future values, we call it as predictions or predicted values. But whereas in time series, we call it as forecast. This is the main difference between predictions and forecasts. Okay, here the time series models broadly classified into three categories. One is classical time series models. The second is machine learning models. The third is deep learning models. Of course, deep learning models, broadly, they are part of machine learning models only. If data is very large and the problem is very complex, and in such cases, we go for deep learning models. But in each type, it can be divided into two categories. Univariate. Univariate means only one variable. If it is one variable, we use ARIMA model. ARIMA is autoregressive integrated moving average model. And this is just similar to in regressions y equal to just only one variable here. And Aremax, if it is a regression type of situation, y on x1, x2, xp, that we call it as multivariate, we use Aremax, auto-regressive integrated moving average. This x is for exogenous input. That means independent variable. In that ex, the second letter x is taken. Aremax is a model for multivariate case, and ARIMA is in univariate. Mostly in MSc, we teach this ARIMA and sometimes Aremax also. The second category models is machine learning models. Machine learning is an algorithm which makes the computer to learn the model. To learn the model means from the data. The machine learning is an algorithm which makes the computer to learn or establish the mathematical relationship between the variables from the data. So deep learning also machine learning, as I told, data should be large and it should be more complex type of data. Complex of data means unlabeled type of data, and in such cases go for this. Here also you have univariate in machine learning and multivariate. In univariate, we have two methods, random forest. This is extreme gradient boosting. Extreme means the second letter x. Extreme gradient boosting method. In univariate, we can use any one of these. In case of multivariate, we use decision tree, random forest, ridge regression, lasso regression, XGB, ensemble models. But coming to deep learning, whether it is univariate or multivariate, each of these models, this is multi-layer perceptron, long short-term memory, convolutional neural networks. These three methods can be used whether it is univariate or multivariate. But in this lecture, it is not possible to explain each and every method with mathematical details. It will be more than one semester course. Just I will briefly review when do you use that, what are the importance, advantages, disadvantages, like that I will. The general idea I will give in this. And finally, I will take some real data and also explain, and most of these methods, except this deep learning methods, I will demonstrate with an example. These are the three categories of classifications of the time series models. Okay, time series is a sequence of observations taken sequentially in time. We know this. The inherent feature of time series is that the current observation depends on the previous observations. Okay, the current always xt depends on the previous values, xt minus 1, xt minus 2, and so on. The time series analysis is one of the techniques to deal with dependency within the data. Usually, in most of the statistical techniques, in testing of hypothesis or estimation, we assume that observations are independent. But once you come to time series, they are not independent. The time series analysis must consider the order of observations into account. The order of observations is very important. It has many applications in science, commerce, marketing, engineering, and other fields. Okay, I will skip the remaining points. Coming to classical time series, this is a ARIMA modeling. The basic assumption in ARIMA modeling is the time series is stationary. Now the question is, what is meant by stationary? In stochastic process, we have two definitions: strictly stationary and wide sense stationary. Of course, mathematically, strictly stationary is very fine. But in practice, no real data follows strictly stationary. That should be relaxing. In time series, and the stationarity is slightly weakened from the second definition, covariance stationary. The fundamental assumption of time series analysis is stationary. A time series is said to be stationary if the properties such as mean and variance of the time series are usually constant throughout time. We assume that expected value of xt equal to mu, variance of zt is equal to sigma square for all t. So this is the assumption we make in ARIMA modeling, and but most of the data in real situation, they are not stationary. Stationary is most ideal situation. Most of the data are non-stationary. So you have to convert that non-stationary data into stationary. From the plot of time series values, if you draw the time series graph, t against xt, if the observed values of time series seem to fluctuate with a constant variation around a constant mean, then the time series is said to be stationary. Otherwise, it is called non-stationary. In the example, we can observe. And if mean is constant, that means you have a trend line, and the variability around the trend line will be more or less uniform, does not change with the time t, and we call it stationary. But mostly data is not real data or non-stationary. Okay, if data is non-stationary, what you have to do is you convert the non-stationary time series data into stationary. The square root or logarithmic transformations are used to stabilize the variations in the series. And suppose if mean and variance both are not constant, first you have to stabilize variance. Stabilization of variance can be done by square root transformation or logarithmic transformation. Virtually the size of the values decreases on taking square root or logarithmic transformation. So with one or two transformations of square root or logarithmic, variance will be stable. Then you have to use difference method. Suppose if there is an increasing type of trend, that means mean is not constant. By differencing, and you can make the mean as constant. So if mean variance both are not constants, first you stabilize the variance and then stabilize the mean. This is the way of converting a non-stationary time series into stationary. But here we use the classical method, the ARIMA modeling method, and the methodology we use is known as Box-Jenkins. They proposed this method. Step 1, model identification and estimation of parameters, diagnostic checking. I don't explain much details. You know all this. And okay, the example I will explain. Let ZT be a time series. And here mean mu variance sigma z square for all t. It is stationary. Otherwise, it is non-stationary. And the Box-Jenkins methodology is valid for only stationary time series. If data is non-stationary, convert it into stationary by stabilizing variance using logarithmic transformation, stabilizing mean by successive difference. We have discussed. And the number of differencings is denoted by D. If data is non-stationary, how many differences you require for stabilizing the mean, that is known as D. So the general model, ARIMA, auto-regressive integrated moving average model, there are 3 parameters. P is known as the number of auto-regressive parameters. Q is known as number of moving average parameters. D is number of differences required to make mean constant. Suppose if D is equal to 0, no differences means just we call it as ARMA model. Of course, it is purely stationary data. You can use ARMA. And most of the time data non-stationary, you have to go for differencing, you have to find a D. If you take at least one difference, then the model will become ARMA. And this is the notation. And here, this phi of B, this is known as autoregressive parameter. It is a polynomial in B. B is a backward shift operator. And this is known as moving average operator. This del B is known as backward shift operator. The definition of this is ZT minus ZT minus K. That is a discussion about the ARIMA model. And the next is ARIMAX. This is in the case of multivariate. But in multivariate case, you should have at least one independent variable. Y is dependent, which is influenced by this independent variable. And this NT or epsilon T or ET, which is known as white noise or errors. And this is C is some constant plus nu of B xt plus NT. Here YT is the output series dependent and xt is independent series. C is a constant. This NT is stochastic difference or noise series of the system that is independent of the output. And this is NT is always independent of YT. And this is the further description of this. This nu B is nu naught plus nu 1B, nu 2B square and so on xt, where xt and NT are assumed to follow ARMA model. Equation 1 is known as ARIMAX model, quite different from ARMA model, because we work with two different series, XT and YT. YT is the output series and XT is the input series. This is regression type. Okay, once you find the forecast, say by two methods. So one is ARIMA model and the another is, let us say, random forest method in neural networks. But how to compare these forecasts obtained by these two different methods? So first what you have to do is you have to find the errors in each method and find these error measures. This is mean square error. Root mean square error means it is square root of mean square error. Mean absolute error means for the errors you take absolute values and find the arithmetic mean. Mean absolute percentage error. Instead of errors, you find the percentage, and that means mod ET by ZT. That is the corresponding value, sum and divide by N. These four measures we use for comparison of two different methods and pick up the model in which, and all these are minimum. Here this 1 and 2 are same. 2 and 3 are also same. This is in percentages. This is the first and third are absolute. So most of the times, if you use MAP and RMSE is enough, or if MAP is also enough, in my opinion. Now, among the classical methods, for example, you take ARIMA, PDQ. For different values of PDQ, you will get different models. Among those all classical models, which you have to, please note here, this error measures you have to use for one method in classical method and one method in machine learning. But within classical methods, if several models are possible, how do you select? So there is two information criterions. The first is known as Akai-K information criterion. The second is Bayesian information criterion. So for all the classical possible models, you find these two measures, and if both are minimum for a particular model among all, that is the best one. But sometimes for some models, Akai-K is lowest. At the same time, Bayesian criteria is maximum. So this is a contradiction we face sometimes. And but among these two, and this Akai-K's information is more efficient, and use AIC and then proceed. Don't use several. Of course, you can use it, but at the time of decision making, you have to use your common sense and your intuition in final decision making. I read in some of the articles. So this AIC is more efficient than Bayesian information. Now coming to the machine learning. So the evolution of machine was done by Arthur Samuel, 1959, who introduced the term machine learning, a pioneer in the area of artificial intelligence, computer gaming, instead of wasting all this time, just I will say that machine learning is an algorithm which helps the computer to find the model. Model means the mathematical relationship between the y and x1, x2, xp from the data. From the data, we find the model by using machine learning algorithms. So this we call it as data-driven modeling. Data-driven model means from the data, we derive the model. Even classical time series also. For the given data, we find the model. Even it is classical time series or machine learning, both are data-driven models. So you are deriving the model from the data given. But here it is a machine learning algorithm. There, that is Box-Jenkinson methodology. Now, no area is left without using machine learning. These days, in the last budget, you might have observed our finance minister, Mrs. Nirmala Sitharaman told, they used machine learning methods in finalizing the budget. And so no field is left without using banking, medical, production, stock market, social media, weather forecast. Yeah, here I want to tell one thing. If you are using the regression type of modeling or array-max in our time series, we have dependent variable y, independent variable x1, x2, xp. But all these variables should be quantitative. Quantitative means at least in ratio scale, or in a layman language, the variable should be quantitative means discrete or continuous. But categorical, if variables are categorical, there are no statistical methods for finding the relationship between y and x1, x2, x. Of course, if y is binary type, yes or no type, we use logistic regression. Only relaxation is there on y's. If independent variables are categorical, I'm not sure is there any statistical method to answer that. But in most of the real situations, y as well as all independent variables x1, x2, xp are categorical. Directly our regression or time series methods in our statistics cannot be applied. One has to go for machine learning. What is a machine learning algorithm? Machine learning algorithm is a heuristic method. Somebody proposed a method which is more intuitively appealing. And then we are finding that. K nearest method of classification. K nearest definition, K nearest neighborhood estimators are there in our density estimate. Same concept it is applied. In decision trees, entropy concept is used. Entropy concept is derived from physics. So machine learning algorithms are just heuristic methods. Intuitively appealing, but using some mathematics or statistics or physics or chemistry. But you don't have any sound theoretical basis like in our regressions or time series. Suppose if you take regressions, how do you find the coefficients? By least square method. And we assume that error also. And we estimate, we test the parameters, we test the model by assuming normality for all this. This type of assumptions and testings are not there in machine learning because they are basically heuristic methods. So if statistical method is not available, one is forced to go to machine learning. So there may be some, for a particular situation, you have a statistical method and machine learning method. Even regression is also the computer science people claim that it is a part of our data science, but regression is not part of data science. Of course, they take it as one of the machine learning methods. And if statistical method and machine learning method available for a particular situation, one has to use statistical method only because it has a sound theoretical basis, and we can say that my decision is 95% accurate, 99% accurate. You cannot make such statements in machine learning. These are all the areas of application. But this machine learnings divided into two types. In the morning, our first speaker also discussed this, Professor Ashish Kumar Chakrabarti. And just I will also touch upon this again. Supervised learning and unsupervised learning. Supervised learning means the data we use is labeled data. Labeled data means for variables we y, x1, x2, x2. Even for photos also. Students of first year, second year, we label certain things. In such cases, for labeled data, whatever you are using are known as supervised learning. And for labeled data, the important applications are classification and regression. Okay, before knowing about the machine learning techniques in statistics, in multivariate analysis, the main applications we used to consider classification, regression, clustering, and dimensionality reduction. All these things we have been studying, and I studied all these methods when I was in MSc from 1974 to 76. At that time, there was no machine learning. We developed, but with certain limitations. The present day order of the day is unlabeled data. Many pictures are coming and text is coming. In applying all statistical methods, our existing statistical methods for classification, regression, clustering, dimensionality reduction are not sufficient. So that is the reason why machine learning techniques are developed. And unsupervised means basically here we use unlabeled data. The main application of this unlabeled data is only clustering. Clustering means one photo is given. You classify into one of the four categories of photos like that. Only clustering is here, and regression, classification under supervised learning. Yeah, this machine learning versus deep learning. The broader area is artificial intelligence. Machine learning is a subset, and deep learning is a further subset. So deep learning is a part of machine learning techniques. As I told, deep learning is for large data sets and complex machine learning algorithm, and then we go for this. Okay, here this a photo I downloaded. In machine learning, you have an input, a car. A car is described by several features. First, you have to enumerate and then find out the data, use some neural network, and then you will finally decide with this classification method, it is a car or not a car. But whereas here in deep learning, extraction and classification both will be combined here. This is the difference between machine learning and deep learning. Okay, now I will discuss one by one the decision tree algorithm. Just I will give only a brief description, no technical explanation of technical terms and computational procedure. Advantages and disadvantages of decision tree. It is simple to understand as it follows the same process which human follows while making any decision in life.
5
So
more
here,
minutes.
please look at here. Decision tree, most of us know here something like a flowchart in our computer programming. And here the terms I will explain. Root node, the starting point we call it as root node. From here the decision tree starts. Leaf nodes. Leaf node means the last end. These are known as the leaf nodes. And splitting. Splitting is the process of dividing the decision node, root node into subnodes according to the given conditions. According to the given conditions, we divide it into 2 groups or 3 groups. And there is a concept known as entropy in physics. Using that entropy, we will do this. Now, again, at this decision, again, this 2 nodes are, and this is the end node. We call it as, this is starting is root and ending nodes are known as leaf nodes. And this is the starting stage. This is the first stage. In second stage, we reach the leaf node. And again, in the third stage also, we reach this. You proceed until you will get. Suppose if this condition is satisfied, this condition is satisfied, this condition is satisfied, this is the answer. If this are satisfied, this is the value of y. So this is known as parent. These are known as child nodes. The concept used for this classification is entropy. So example I am not discussing here. The review of random forest. Just I will give the idea and I will leave it. Suppose if data is very large, drawing decision tree is not easy. If you are teaching in data science decision tree, if you take just only 10 observations, y, x1, x2, x3, it will take 1 hour for only decision tree. But there are 1,000 such sets of observations. Drawing decision tree is very difficult. Even on computer also it will take more time. So the alternative suggested is take this bagging method. Bagging is nothing but bootstrap samples in our statistics. And if there are 1,000 observations, from that you select a simple random sample with replacement of size 10.
1 more minute, sir.
For each you draw a decision tree. And suppose you have drawn 10 samples, simple random samples without replacement. For each you find an output, and which output is repeated majority number of times, that is known as by voting, you will decide the output. This is the concept in random forest method. It reduces overfitting in decision trees and helps to improve the accuracy. Just have to discuss here what is overfitting. Normally, in machine learning algorithms, the entire data is divided into training data and testing data. Training data means we fit the model. And if you ask for the training data, definitely they are very close to the actual values. But will the model developed in training data is suitable or accurate for the test data. If it is true, test data also. If it is not true, we call it as overfitting. Overfitting means the model is working well in training data, but not working well for the test. If you use random forest, because you are random sample without replacement of some K. So naturally, the overfitting may reduce and accuracy may be improved. It is flexible for both classification and works well, both categorical and continuous values. Of course, all machine learnings are recommended for category. The third is, okay, here it is represented. The hyperparameters tunings means these are the parameters you have to choose in advance before running the program. Just the basic idea is given here. This is all data sets. We are taking random subsets. Suppose this is 1000. So I take 100. 100 first simple random sample with the replacement 4. For each you draw decision tree, find the answer. So you will get 4 answers and pick up the one which is repeated maximum number of times. By voting, that is known as the best answer. So this is the pictorial representation of this random one. Yeah. Extreme gradient boosting, some more powerful learning introduced in the last 20 years. Originally designed for classification problem, but as will be seen, it can be profitably extended to regression. The motivation for boosting was a procedure to combine the outputs of many weak classifiers to produce a powerful committee. Here, we combine, if you look at the, just we take simple random samples with replacement. But here, you have to identify the weak that you have to club with others. This is in bagging. Bagging means simple random sample without replace, same sample. But here, different observations are combined here. If different observations are combined, we call it as boosting. Now in machine learning,
sorry for time off.
Yes.
Time is over, sir.
Boosting and bagging, these are the two methods. If you are using boosting, it is known as extreme gradient boosting method. And how much time? Ridge regression, I will just give the ideas. Yes? Anybody want to say anything? Okay, ridge regression is if there is multicollinearity in our regression analysis, we assume that there is no multicollinearity between variables. If there is multicollinearity, instead of our ordinary linear regression model, we go to this ridge regression. Here the details. This lasso regression is, it is different from other methods. Linear regression and ridge regression. This is the thing we minimize. Yi fx square of the errors, sum of the squares of the errors, plus absolute value of the errors also we introduce
Time is up, sir.
in minimization. That means weights we are trying to minimize. This is known as lasso regression. And ensemble models. Ensemble models means it is a hybrid models. We take different methods, we find solutions, we give different weights, and then we find a final solution. Ensembling means combining several outputs with certain weights. That is known as ensembling. For example, here you see, this is the original training data. Different data sets we consider. We find different classifications. Combining these outputs with certain weights, we get one output. This is known as the final output. Individually, if error is 20%, collectively the error is 10.4%. This is just ensembling means combining. This combining, there is a term known as committee model. It is there somewhere. And this MLP, from here we are starting the deep learning methods. This is multi-layer perceptron. These are the inputs. This is the output. There are two layers. It is a feed-forward network, and this also works very well if the data is large. And yeah, this is a long short-term method. Yeah, this also, these are known as cells, and these are the values coming from hidden layers. This is known as forget cell, input cell, and output cell. Lot of technical terms are involved in this, not possible to explain. CNN also, convolutionary neural networks. Here also input layer, convolution layer, pooling layer. Finally, you will get output. So these are the just brief idea about this all models, because in 45 minutes I want to cover. Actually, here I stopped sharing. Now I will share this data set.
So we already crossed the time, so 2:40 was the time. So
Is this data visible? This is Infosys share market price. Date I've taken from 1st March 21 to February 28. So till end of February. And here Y is the closing price on each day of the Infosys share price. This X1 is total traded quantity. This is Nifty 50 value, index value I have taken as X2. So there will be always a coordination or correlation between Nifty 50 and the price also we can expect. And the quantity also, if these two also correlated. But quantity and Nifty index are logically they are not correlated much. This type of data.
Thank you, sir. And sorry for.
Susan, can you give me 3 minutes?
So we already crossed 10 minutes, sir.
Huh?
You already took 10 minutes, sir.
Okay.
Thank you, Professor M. Krishna Reddy, sir, for your talk, sir. And to narration series,
I will
time
stop.
series. To narration series, the time series will catch you all. Thank you, sir.
Okay. Thank you. I wanted to explain example. Okay, no problem. Thank you all for giving me this opportunity.
Good afternoon, everyone. Good afternoon, everyone. I take the privilege to introduce Dr. Koduri Srinivas Garu. He is a former senior scientist, head of database systems of National Remote Sensing Center, Department of Space, Government of India, was responsible for automating and monitoring entire production chain for data products, generation of Indian and foreign remote sensing satellites at Data Processing Area, NRSC, with about 20 scientists. He worked as visiting professor at 2 universities of Tamil Nadu. His areas of specialization are 3D imaging, designer large format image scanning system for 3D and virtual reality, rational function optimization techniques with lazy search for geometry and virtual reality, Lexi search based software engineering and image understanding. He has over 27 years of computing experience in highly reputed organizations, which include 20 years of NRSC. He designed 3 major releases of OOPS, OOPS-based Integrated Information Management System for proportionalized satellite data product generation. Designed very large-scale real-time satellite data perception, image processing, and GIS facilities as Deputy Project Director. He designed image processing software, used Lexi search for nonlinear optimization problems for rational functions with several parameters demanding global optimal solutions. He designed multi-million-dollar training programs on ISRO, remote sensing programs for international clients for NRSC. He has completed his BSc honors from Osmania University. He also has completed MSc Applied Statistics from Osmania University. He was awarded with doctorate from University of Hyderabad. He has 19 research papers, over 40 internal technical reports published in leading international journals. He was a fellow of Royal Statistical Society, UK, fellow of Institution of Electronics and Telecommunication Engineers. He was actively associated with IEEE. He published 2 papers, conducted 7 international conferences. He was a senior member of IEEE. He was an outstanding volunteer. He has won several prestigious awards for his chapters in IEEE. He was Best Reviewer Award at Conference on Software Engineering and Computational Intelligence. And he was an external examiner for many subjects for many leading academic and research institutions, including University of Hyderabad. Now I request sir to, please start your lecture, sir.
Am I audible, madam?
Yes, you are audible, sir. You can.
Okay.
then I have to see the presentation material on the screen. Can you see that?
No, sir, you need to share the screen first and select the PPT.
How do I do that?
You first need to open the PPT, then share the screen, select the PPT.
I opened that PPT. Where is the share screen?
Below the screen, black screen, there is a green color button, share screen. In the Zoom, there's a share screen button in green color. Come back to the Zoom screen. Below you see a share screen button. Chat, share screen, record. That green color, share screen.
What is that?
So once close the PPT, just come to the Zoom.
Go to the Zoom screen first.
Come to
Zoom,
PPT.
Zoom. No, first go to Zoom.
I am zooming.
There is a share button.
Below the screen, at the bottom,
Below
you
the
see share
bottom of the
screen.
screen. At the bottom, this Zoom meeting screen, at the bottom, there's a green button.
Notes, comments, then you have got 82%. Fit to slide. This is at the bottom of the screen. This is what I'm seeing.
Share screen. First share screen.
Sir, you first close all the windows what are there. Just open the Zoom. Can you see all the speakers, sir, on the screen? All the names. Can you see
just
them?
now.
Yeah, below them, you just scroll a mouse on it. Just put the mouse.
No, just let me
You'll see
log out.
share screen. Can you see the share screen button, sir?
Yeah, share that too.
Yeah, you need to click on share screen. Now, if the PPT is already open, select the PPT.
I opened.
Yes,
Are you
yes.
able to see
Done.
this?
Yeah, it is opening, sir. Yeah, now make it on full
Okay,
screen.
audio is also there.
Yeah, audio is also there. We can hear you. Just make the full screen, sir.
Thank you. Respected chairman of the session, distinguished delegates, at the outset, I would like to thank the organizing committee members. In particular, thanks are due to Hargopal Garu, Rajashekar Reddy Garu, Raghavendra Rao Garu, then my venerable teacher, Professor Krishnareddy Garu, then Professor Jayasri Garu, Professor Bhattacharya Garu, and I am sure many other people whom I have known within the departments of Osmania University as well as Central University. Thank you so much for granting me an opportunity to be before you all. I intend to take you people through Lexi search for software engineering. All of you know that
satellite collects information from something like 830 kilometers above the Earth. That is the normal altitude. Lower altitudes, of course, we can lower it to much lower heights. And we also have other types of imaging platforms. For example, it could be aerial. Okay. Now, the whole point here is we would like to relate this data, which is collected by the sensor, to a map that is coming out from Survey of India. In this context, we use what is called as rigorous photometric sensor models. There are slight differences with respect to the aerial and push broom scanning systems. So I intend to describe some features that are peculiar to the spaceborne push broom systems when you compare it with the aerial, then enhancements that are proposed to handle the complexities of the spacecraft model, and to improve the numerical stability, we use LexiSearch to solve. LexiSearch was actually developed by Professor Pandit in a totally different context for solving NP hard combinatorial programming problems. And that's what actually over a period of time got used into the search-based software engineering techniques. So using this example, because you people are very comfortable with the statistical methodologies, I thought this may be a nice mechanism to share the LexiSearch potentials. LexiSearch is also used for commercial applications. There are many of my students who are working in companies like Infosys who are actually putting it for business type of applications, but that is skipped. Now, there is a station management system in organizations like Department of Space, where we actually connect to the satellite and collect the data. After it is collected, we subject it to quality assessment. We generally collect it with more than 1 or 2 antenna systems for the sake of redundancy, and whichever is the better of the data, that we use it for processing. Now, there are many types of processing. The whole thing started with Landsat MSS in 1970s, and then Landsat TM came. Then SPOT came to simplify the Landsat imaging processes, and IRS follows the SPOT imaging concept. And there are many other DP systems that we have, for example, Cartosat, then we have got P5 for stereo, then we have got RadarSat, then we have got non-imaging sensors like, handling the velocity on the ocean areas, okay? Now, from the software lifecycle point of view, we use IEEE 12207 standards. Software development process is the third of those processes where we get into the software design, developments, and the entire life cycle. So I'm keeping the game simple. There are many types of models, but I'm keeping the game simple to the model that most of you will feel comfortable. First, you elicit the requirements, then you do the analysis. This is requirements is a brainstorming activity. Then you get into a situation of analysis where whether the number of products you want to generate are actually realizable from the platforms you are using. So this is a totally systems view of looking at it. Then design is dealing with the internal structure and the algorithms associated with each of the components, how you actually create an ensemble, and then you get a particular activity. For example, it could be for radiometric correction or geometric correction and the like, and then you integrate it into a system. By system, we include for sure the hardware, the software, and all other things that come. For example, there could be a GUI, there could be some third-party library, there could be software coming from, for example, Intel, then MK, our math kernel libraries and the like. All these things are looked at the design stage. Then comes the coding aspect and testing. Deployment in types of institutions like ISRO, we have a slightly different view. We deploy it, but we put it on a development server. We just keep that activity in that mode for the users to test it out for about 90 days. Then again, we review
the performance of the system before we actually put it on what we call as a mission critical system. This is a slight difference between what we do in practice versus what this current slide is telling. Now, coming to this specific application dealing with respect to the rigorous modeling for data processing, there are many changes that keep on happening. For example, the matrix structures, they keep changing for each model. When I say model, I'm not talking about a statistical model. This is the physics of the optical model. It could be a pinhole camera. It could be a lens with distortion only along the radial. It could be a lens with distortion along the radial and the vertical, that is tangential. And there could also be a skew. So each is a different type of model here. So the word gets used loosely, but don't confuse. Okay. Then we have additional parameters coming into picture. Generally, if you are using things like films, that film loading may not be 100% exact. So there is slight rotation that gets induced, and things like that are addressed with additional parameters. For each type of additional parameter, I think I have seen 39 of such parameters in my life. For each parameter, the structure of the matrix go through a major change. And there is another thing when you're dealing with least square solutions. This is based on iterative solution of partial derivatives. Obviously, partial derivatives, once they step in, you will never have locally optimal solutions, but globally optimal solutions. I mean, you'll never have globally optimal solutions, but locally optimal solutions. So you would like to move away from the local and have a strategy where you can go for globally optimal convergence. And this is where LexiSearch comes into picture in a very big way. Then there is also another point that I need to mention, that is most of these equations deal with terms of sine and cos, that is rotation matrices. So these are essentially transcendental equations, and therefore, you will have more than one solution stepping in. Conventional techniques, even the best of the packages I have seen in my so many years of service. I mean, each package runs into several crores. Okay, some are as expensive as 12 crores. Okay, even these do not actually give all possible solutions. This is where again, the LexiSearch has come out to be very handy in a very big way. Now, obviously, once you are heading towards that, you would like to select the optimal solution. But in many cases, for example, if the area is very large, you don't really need this kind of precision. Okay. For example, if you are into crop, dealing with banana or paddy, you are talking about 100 acres. You are not talking at better than 1 meter precision. Nobody needs that kind of things. So other potentially alternatives that are actually inexpensive for computational processing point of view are also to be kept track of. Then we have a concept in modeling where photo coordinates, then ground control points. By ground control points, I'm talking about a feature on the earth that you can easily distinguish. For example, it could be Buddha statue in Tangman. Okay. So when you are trying to select such parameters automatically for modeling point of view, then it affects the entire software life cycle, starting from the requirements to testing phase. Then you would like to have web-based reports and analytics stepping in a very big way. Once you have actually finished the processing, then you'd like to store all these inputs and outputs for future use. So that would include all the tables, input, output, ground control points, terrain control points. That is, other than the surveyed points, we get very good points after processing. So these also become potential candidates for subsequent data set processings. Then tie points are what we use for stereo type of applications. Now, we are talking about software. Just a minute. We're talking about software testing. Here, I'm just keeping things very loose and light so that you don't really worry about it. First is, are we building the product right? That is called verification. Another question you'd like to ask is, are we building the right product? I mean, is it going to work? That is called validation. Then you also have manual types of testing, automated testing, black box testing. Black box testing in this particular context is for end users, testers and developers. They don't have the domain knowledge, but they are going to, give the required parameters to ensure that the project software starts running. So such testing is black box testing, but where domain expertise comes into picture. For example, if you're talking about matrix inversion failure, or you're talking about singular value decomposition, then additional expertise does come into picture where you'd like to talk to mathematicians and statisticians. And then there are many types of reports where you also would like to interact with the people from the astrophysics point. So such kind of underlying understanding would be under the domain of what is called as the white box testing. Then coming to connect with you people, there's a lot of statistics associated with sensor modeling. In fact, for about 5 years, I enjoyed this and I just didn't know how time flew. So statistical test for significance comes into picture with respect to the way you actually collect the ground control points using the survey instruments on the field. Okay, so there you get into T, F, chi-square and all those kinds of distributions. Then you'd like to test the model with respect to this exterior and interior orientation parameters. By exterior orientation parameters, I mean where the satellite lens was, and then by what angles that is actually capturing the image. So you'll have 3 angles across X, Y, and Z, and also you'd like to keep track of the lens center point. That is the exterior orientation parameter. And interior orientation parameters deal with focal length, then what is the center point pertaining to the imaging plane, that is the center of the picture. Then what are the distortions, how we would like to model them, and the like. Photo coordinates, that is the image coordinates, that is the Buddha statue on the image. These do not need any testing. Okay, but in many cases, particularly the exterior and interior orientation points, you may not have the privilege to go through the testing because the enemy terrain will not give you the luxury to go and control, collect those ground control points and the like. Then I already covered matrix theory comes into picture. So SVD, Forbinius norm, triangular techniques, rank deficient matrices, how do you handle? Then there's one way, two way, the nitrative least squares, Liebenberg mark dot, lasso regression, ridge regression. Then search techniques are important, particularly in the context of the spacecraft regress models. I belong to the spacecraft segment and I have put it to very good use, and it has got me a lot of visibility across the globe. Now, this is another method of looking at the software life cycle. You have to brainstorm to gather the requirements. Then by design, you are actually talking about including the design documents. In India, we are very poor about these design documents. And then the way we build the prototypes. By development, I have already mentioned earlier, for us, it is actually a story of looking at the hardware, the software, so many other components. Then when you actually build and then elicit the feed, we also take into account the throughput concentrations coming into picture there. Then we have a quality assurance feedback to identify the bugs. And again, we then consider it for deployment. When we deploy, like I said earlier, we put it on what we call as a development server and give it a try for 90 days and elicit the feedback from the respective experts in the department. And once all the bugs and other issues are resolved, then it goes for deployment, and that becomes what we call as a mission critical system. Now, let us come back. When we are doing any modeling, particularly in the context of least squares, we would like to look at the lessons we have learned from the computing era. Iterative solutions, like this particular one for this regress sensor model, uses least squares with iterative solutions. So when you're dealing with any iterative solutions, Lorentz curves have already shown that the same equation can diverge to a totally different solution with the same set of parameters. A small change, that is the rounding of error, can actually take you into a totally different world. That's why people say, the butterfly flapping its wing can cause a cyclone. In fact, you get into situations far worse than that. It keeps on working. I ran into that situation time and again, keeps on working, and you don't know that hell has broken loose. The computer keeps on telling you it's going great, but actually it's not. Now, that is the worrying part, but the nice part is the same thing has been actually looked in a totally different way. And, this understanding about why we are diverging has actually simplified the weather prediction models from having 12 parameters to 3 parameters. Obviously, there's a lot of trade-off when you're lowering from 12 to 3. So you need to strike a balance and be flexible that, okay, there are certain limitations, but in any case, it is going to yield the required, predictability. Now, I'm coming to the Lexi search process because this is something, that has proved to be priceless. And I thought I'll share my wisdom. Lexi search was introduced by my PhD guy and the venerable sage like a scholar, a very simple man. He was from IIT Kharagpur. He went to University of Dibrugarh, subsequently to RSC Warangal, then came to Usmania University, then went to Central University, and again retired from Usmania University. I did my PhD under him in Usmania University. And this is the technique that has got me a lot of visibility across the globe. And when I was actually developing it, I actually looked at it as an abstract problem dealing with traveling salesman problem, which is an NP-hard problem. And, the definition is easy, but, the solutions place simply explodes combinatorially. If you have n nodes, factorial n is a solution space. So a small matrix like 10 by 10 would mean factorial 10 is a solution space, which runs into millions actually. Okay. Now, Lexi search has got a bit of Indian tinge also. It goes back to maybe about 1,000 years or more to Mr. Pingla, who actually started using it for many combinatorial problems. But it is left to Professor Pandit to come out with adding a metric. What Pingala did not do was to look at metrics and to enumerate these metrics with so that you can always work towards a globally optimal solution, or you get a feel for how far your existing solution is away from the globally optimal solution. So the search for the process, I'd like to restrict it with respect to the traveling salesman problem example. Professor Dr. Bhanumurthy of Usmania University and myself, we are the two people. He programmed for knapsack. I programmed for traveling salesman problem a little later than, maybe 1 or 2 years down the line. He was my 1 year senior. Many other seniors are there who have actually solved for this traveling salesman problem and knapsack problem, but by hand. But it was only when this software of mine was developed, then we started actually understanding the advantages that we have over existing branch and brown techniques. For example, a 10 by 10 matrix was all you could process with branch and bound techniques of the systems of 1986 era. Whereas with a PC286, during that time, I could easily process a factorial 50 problem with Lexi search for traveling salesman problem. Factorial 50 is a huge big number. And the best part is the whole code is less than 1.5 pages, including the driver program. whereas branch and bound technique was running into 66 pages. Okay. Now, let us take the definition of traveling salesman problem. What it says is a traveling salesman starts from one city and returns back to the city without revisiting any of the cities. He has to cover all the cities, and your interest is to find the smallest path that is actually possible. So now let us come to the definitions. I will not go very deep, but let A, B, C, D be the 4 nodes to be covered. Set of partial words that can be completed are A, B, C, D, like in a dictionary. Similarly, if you start with B, it will be B, BA, C, D, etc. Similarly, C means it will go C, A, B, B, D. D will start with D, A, B, like in a dictionary. Okay. Now, if you are at AB, then A becomes the leader. If you are with A at ABC, AB also qualifies as the block. Okay. So now there are other definitions that deal with what is a block, what is a super block. A and B are always super blocks because they are the smallest letters that you can actually have. Then a block, as you go towards a solution inside, can have many sub-blocks. For example, for A, it could be AB, ABC, ABCD, etc. You are entering the blocks inside. And all incomplete blocks are used as leaders. That is as far as Lexi search is concerned. But the nice part that Professor Pandit introduced is, he came out with 3 simple operations. One is you go inside if you think, there is a promising solution. So that is called the go to sub-block, that is inside. Now, if that is not promising, for whatever the reason, like I will show you with an example, then you just jump, but go to the next element. That is called jump block. But there also, if it is not promising, then don't consider all the blocks with that particular letter, but go to the next higher block. So that is called jump order. These 3 are the fundamental steps that Professor Pandit has introduced, and that is now history. Another point that I'd like to mention here is the examples he has chosen are also very simple and enlightening. In the sense, there is only addition. There is no subtraction coming into picture anywhere. Forget matrix, any type of multiplication or even division. So with a very simple operation, like you only add, he actually has come to prove that this particular technique works wonders. Now, let us take a normal matrix. The diagonal elements are infinity. So from a digital point, I just made it 999. Then, from node 1 to 2, the distance is 5. 1 to 3, it is 13. 1 to 4, it is 8. And 1 to 5, it is 33. Likewise, the rest of the distances are covered. Now, what you do is remove the most minimal element in that corresponding row or column. So you get into a situation where the matrix becomes like this. Now it will have zeros. Now all these values added together becomes what is called as the bias. Now you see from node 3 to 2, you are moving with a cost of 0. From 2 to 5, you are now moving with a cost of, from 5 to 1, you are moving with a cost of 1. Similarly, 4 to 5, you are moving with a cost of 0. But now you see here, what has happened? The next node that actually qualifies is 2 to 1. But 2 to 1, if you go, you are revisiting back to 1. Or maybe if you have come this way, from 2 to 1, again, you can go back to 5, which is not allowed. So what you do is that guy you will skip. And automatically the next solution has become the optimal solution. So you can see for factorial 5, that is 5 into 4, 20 into 3, 30 into 2, 120 solution space. In the first solution itself, we have got the exact answer.
5 more minutes.
I hope you people get a feel for what this Lexi search is about. So you have a very simple, elegant method of actually searching out for an optimal solution. And this is what we are going to use. I'll just illustrate with this satellite image processing example, which actually got me, like I said, it was actually, it's not the recognition point. It was actually my, or it saved my skin. Otherwise, I possibly would have to pack my belongings and make a statement, I'm unfit for scientific computing. Now, let us consider this simple optical model is a simple camera. By collinearity, we mean that the object point, that is this person here, the principal length and the image point, they lie in the same plane. In other words, we are exploiting the principle associated with the optics that any line passing through the principal point will not bend. It is not that the image is not getting processed with other rays. The other rays are definitely passing through the lens and they form the image. But for modeling point, we don't need. Now, for a typical example, we just need 3 to 5 points. 3 is minimum, but 5 to 7 points, you can do this particular modeling. By modeling, what is it we are doing? We are trying to establish a relationship between the image space here to the object space. The only other component that comes into picture is the rotation. Of course, there is an unknown parameter called K that actually deals with the distance from the object up to the image point, which we all don't know. But then you just remember, there is also another point that I have to tell. That is the definition. X0, Y0, and F. They deal with the center of the photograph, X0 and Y0. F is along the direction in the Z-axis to the principal point. And because we are actually computing the distances from here, it assumes a negative value. Okay. Next, X, Y, and Z. These are the object coordinates. It could, if it is a point on the head, I will call it as point A. If it is a point on, let me say the leg, I'm going to call it as B. And this is one vector that constitutes the object coordinate distances. When we pick up a point like, let me say, this Buddha statue, we are actually using your, all of you are using your navigation tools through mobiles these days. Lat, long, and height is what you're going to get for every point that you can prefer to collect. All you need is to take your mobile and keep it there, and the satellite gives you the ground control information. XL, YL, and ZL, this we get from our satellite instrumentation. So one vector deals with this side, that is the object side. The second vector actually deals with what is happening inside the image plane. Then there are other definitions, which I'm keeping it simple. You don't need this kind of math, but the word U deals with the first line multiplied with the object vector. The vector V deals with the second line multiplied with the object vector difference. And the third line is W, dealing with the third line and the object vector. Okay. Now, please remember, the third line is the focal point, which is strictly speaking a constant. Since I cannot know what is K by whatever the means, what we do is we divide the first row by the third row. We get one set of equation, and the second row again by the third row, because it's constant. So you end up in a situation M1 divided by M3, like whatever these terms put together. Similarly, M2 plus whatever these terms are there, divided by this. So this is how the projective equations are now realized. We say the word projective because the lens is actually reducing a 3-dimensional space into a 2-dimensional space. Now, if you have more than two images, then you can actually collect the collect for the height. Okay. So now this M is the rotation matrix. I would need at least another 5 minutes, sir. I'll wind up.
Okay, sir.
Okay. The M is a rotation matrix which is orthogonal. Okay. So all you need is to get its transpose and you end up getting as the inverse equation. The point is orbital modeling is coming into picture for what is that? Realizing the parameters. Subsequently, for rendering purpose, you are going to use this inverse relationship. So modeling is one part of the story. It is very time consuming, very involved job. But once that stage is crossed, that information can be used for several other images which are contiguous in the same path. Okay. Now this particular matrix, this image vector, is dealing with interior orientation elements, like I will show X0 and Y0 for satellite, this lens distortion model change for additional parameters. Then object oriented, XL, YL plus this rotation, they constitute what is called as the exterior orientation elements. Then you have the survey points coming into picture. And the method of evolving these partial derivatives, that itself is a great exercise. But once you model the raw data with this sensor model outputs with one single resampling technique, you can generate an exact precision rectified image which is exact to sub-pixel accuracy. What I'm saying is, if your pixel resolution is 1 meter, so you'll get better than 0.5 meter resolution. Then we have a lot of testing group dealing with interior orientation, exterior orientation, ground control points, then how this nonlinear least squares is behaving. I'm skipping all that, but I just want to mention that this X0, Y0, they are modeled, and this modeling varies from for different sets of additional parameters. So, like I said, additional parameters deals with the distortions coming into picture in so many ways. These are some, I just listed 12 of them. And the lens distortion photograph, this is one is the barrel, the other is pin cushion. So we actually model X0 and Y0 as a function of these two equations, which are nothing but polynomials of K1, K2, K3 taken into picture. And R is nothing but the square root of the distance between X and Y. Okay. And the same equation that I have shown earlier, this is AV, which is the residual vector. You don't worry about it. The B, this is dealing with the photo coordinates, and this double dots, they actually deal with the survey coordinates. So once you put it into least squares, you get into a matrix like this. And this again further by simple mathematics transforms is reduced to an equation like this. And now you can say this is y is equal to x beta plus c. So you use iterative least squares. Now for implementing Lexi search, this matrix delta is actually modified with respect to the diagonal elements. That is a straightforward transform dealing with Frobenius transforms. Now, you have very interesting structures coming into picture with respect to the search techniques. One is, this actually deals with the 6x6 for exterior orientation elements. This actually deals with the transformation about how photo coordinate is related to its ground control point. And these are actually the covariance matrices dealing with the ground control points alone. So the net message here is you are not inverting the matrix per se, but you just focus on inverting the small matrices, and that is a very, very efficient process. And for these set of elements, like I will show, for this lens distortion, the parameters have changed from 6 to 2 mn. By here, M stands for more than one photograph, which is very important for applications like stereo. And then, 9 are the interior orientation parameters. The other two, anyway, of course, will not change. should have been 6 if it is a single photograph. Otherwise, it will become 6M, and the number of GCPs that remains same. Now comes the push broom imaging. The satellite is moving in an elliptical orbit, and it is actually tracing the ground path, and the Earth is rotating. This is the fundamental principle. Now, if you have put your sensor along the direction of travel, that is called push broom. If it is actually put in the perpendicular direction, that happens for satellites like Landsat, it is called wish broom. We are actually focusing on push broom in ISRO, and the advantages you have is, it moves in a very close, well-defined orbit, almost close to circular elliptical orbit. The images are acquired at a constant time interval because there is no gravity in the space, and as a result, all coordinates have the same scale. That's very important. Okay. Single image consists of a number of consecutive lines, and Earth rotation is also a part of the matter. What I'm trying to tell you is, you can visualize a pencil with sensors, like in a photocopier. This is going to capture the ground on the Earth. So actually what you are having is a collection, it's a series of lines that is coming into picture that looks like a contiguous image. That is how we actually sample the satellite travel time. Okay. So this is the ground track. That is also the same flight track for push broom imaging. For wish broom, it will be perpendicular. Okay. So now what that means is, along the direction of travel, one of the vector becomes 0, which means your variance covariance matrix has become rank deficient. So we have shown that in our study that the satellite is affected only by 2 parameters of the 33 parameters. Okay, one is along the direction of this right ascension. By right ascension, we actually look with vernal equinox as the basis, and from there, we in a day we cover 360 degrees as a function of the Earth rotation. That is, Earth is moving 360 degrees in a day. That is what this right ascension node will tell, but it is with respect to one particular point called vernal equinox. Next is, from this vernal equinox point to the place where this orbital plane of the satellite meets the equatorial plane, that is where this particular angle will be. From there to the nearest point of the satellite orbit, that is called the perigee angle. Perigee angle plus a place from this perigee to the current location of the satellite. I mean, every line, that is called the traveled angle. So true anomaly is nothing but perigee plus traveled angle. The net message is, we have successfully shown that only 2 parameters apply. That is, this right ascension node and the argument of perigee for your modeling. Okay, these are the other things that I am skipping. So once you model, we actually use stereo imaging. We have 2 cameras with about 3.08 milliseconds time difference, 3 milliseconds time difference. We actually bring the second camera to the position of the first. In these 3 milliseconds, very little of the ground conditions change, and you don't worry about the cloud or the shadow induced by cloud. So you have very ideal conditions to do that. So this is what permits 2 images we are able to collect, and therefore, using the same model, we are able to generate the height of the actual place where this particular point of interest is. So sitting here in Hyderabad, I can safely estimate what Mount Everest height would have been, or what Kargil, the Tiger Hill, or whatever other features of interest that our people are interested, that height is. Now, improvements is, we actually focused on, you are anyway dealing with partial derivatives. Supposing you go wrong, you'd like to verify with numerical methods. Then earlier people were using normal simple inversion techniques, then they went to LU decomposition given the complexity, but I replaced them with SVD, and actually that was very much appreciated in Cambridge University also. The nonlinear squares, we use Liebenberg mark dot approach for singular matrices because it permits you to meddle with the diagonal elements. Why you change the diagonal elements is off diagonal element modification means it's a symmetric matrix. You have to modify twice to get the same accuracy. This, if you avoid and if you stick to this kind of approaches, only one parameter that is affected. For example, there I was mentioning the right ascension node, and the second parameter is this travel true anomaly. These two parameters only we will make the modifications, and you can successfully get into a situation where you are dealing with non-singular matrices. And the other point I must note is you're going to change a parameter from 0.1 to 0.01. More than that, the whole model goes for a toss. Okay, and then you get into this lookup table based image rendering by Bragg projection. So Lexi search proved to be very important for us to actually make the modifications for the parameters for this right ascension node and this traveled angle using Liebenberg mark data approach. Now, why do we go for Lexi search is for satellite imaging, it is well known that W often becomes 0, which means already you are dealing with a numerator 0, and now the denominator is also becoming 0. You are now dealing with what is called as indefinite forms. So when you have this kind of situation, you have no choice but to get over this least square theory and look for search-based techniques. Search-based techniques are not new. In Usmania University, there are many operations research books, and also, I have seen Richard Bellman making a strong case for all mapping equations only by dynamic programming. Then there is also another third case where I think that was from this Sham series books, where they clearly say if the partial derivative is not there, you only use search techniques. And like I said, Lexi search proved to be very efficient compared to branched form. So since I knew it, I just had taken a very simple call. Now, two-stage, first you do it with conventional approach. It will stop somewhere. Then, use this iterative techniques. That is, you keep on feeding the new increments to the parameters time and again into the model. Now, Lexi search for aerial is handled only on the three angles of X, Y, and Z axis, which we call as omega phi and kappa. And the residual are enumerated as rational functions that I have shown. That is, that vector of the image side and the vector of the object side related by this rotation matrix. So we could conclude and show that optimal solution for satellite imaging is in the direction of the kappa angle, which actually is affected by two parameters, that is by true anomaly and the right ascension node. The rest of them are exactly static. I can safely assure you that even at 12th or 3rd decimal place, they were exact. So to conclude, search-based techniques are a great help in software engineering. They are very helpful in migrating to cloud platforms. For example, this particular laptop is actually having 8 cores. It is an i9, and we can directly connect to cloud under Python, Java, but Fortran still is Fortran. It actually gives very exact results even of date. In fact, just to tell you people, 80% of Intel revenues for software come only from Intel Fortran. So we also in ISRO and DRDO for all astronomy related activities use only Fortran. Of course, I use Python, I use R, I use Java. That's a different story altogether. Okay. So Lexi search is the one method where, because you have initiated a search, because you are incrementing the parameters time and again, you are actually moving away from a locally optimal convergence to globally optimal solution. Okay, and this is also very useful. For example, whenever you are into any regression techniques, where you are changing the parameters, Lexi search helps. That's all I wanted to say. Thank you. If there are any inputs, please let me know. Thank you so much, sir.
Thank you, sir, for giving the insights of software development process and Laxi search process. Thank you, sir. Now there is a tea break, sir. We'll get back at 4 o'clock.
Thank you, madam, for granting me the opportunity, and let me also take this opportunity to thank all my mentors and others who thought I am worthy of delivering this lecture. Thank you.
Thank you, sir.
Yeah.
Padmasri ma'am, we can start. You can introduce the speaker. Please unmute.
Hello? Hello?
Yes, we can hear you, but speak little louder, ma'am.
I can't hear your tone. Video tech supporter. Yeah, I'm starting, sir. Good evening, one and all.
Yes, we can hear you.
I am Padmasri, Assistant Professor in the Department of Statistics, UCS, Usmania University. It's my immense pleasure to invite the speaker, Dr. Vishnuvardhan sir, who is an Associate Professor in the Department of Statistics, Ramanujan School of Mathematical Sciences, Pondicherry University, Puducherry. He is also the Deputy Nodal Officer and All India ranking formats for Pondicherry University. His main research areas of interest are classification techniques, ROC curves, multivariate analysis, and regression diagnostics, and also computational statistics. Sir has also received many awards like Young Scientist Award during 101st Indian Science Congress, which is held at University of Jammu in Jammu. Young Statistician Award from Indian Society for Probability and Statistics, and Mrs. Bhargavi and Professor C.R. Rao Award for Best Poster Presentation. Sir has guided 6 PhD students, out of which 2 are awarded doctorates and 4 are in the progress. He has guided 45 PG projects and 2 research projects. Sir has authorized 2 books and edited 1 book. He published 72 research papers. Sir has given 59 invited talks at workshops and also faculty development programs, both at national and international platforms. He also gave 45 conference presentations. He has organized 7 workshops and conferences. Sir is a life member in Indian Society for Probability and Statistics. He has a membership in Indian Science Congress Association, Indian Society for Medical Statistics, Calcutta, Statistical Association, and Society of Statistics, Computer and Applications. Now, sir is going to give a lecture on data analysis using R, which is a menu-driven approach. Now, I request sir to give his precious lecture and enlighten the participants. Thank you.
So we can't hear you. There's some problem with your mic, I believe.
Hello? Hello?
Yeah, ma'am, there was some issue, mic issue with sir. So
Yes, now audible, sir?
Yes, we can hear you, sir.
Yeah, thank you. There was an issue with audio. Now it is rectified. No problem. Yeah.
Okay, you can share the screen, sir.
Yes. So first of all, good evening to one and all, and let me thank Dr. Padmasri and the organizing for introducing me, and thanks for giving this opportunity to share some thoughts about our programming and ISPS and the Department of Statistics of Osmania University. I'm so much thankful, and today, as I have given the title, data analysis using R, a menu-driven approach. So most of the time, you might have I mean, you might have heard many lectures on data analysis using R or different topics that covers in R programming. But now, recently I have come across some sort of a different version of R, okay, which was created by a team of people, where that is a user friendly and it works as a menu driven option. Okay, so today I am trying to share that information with you all, that in what easiest manner we can do all sorts of basics to advanced data analysis in R. Okay, I no, my focus is to just explore and share the possibilities of doing or conducting the data analysis using a menu driven approach, because most of us, we have worked with SPSS Excel in a menu driven platform, and particularly non-statisticians, when R has emerged or has come into the main platform, non-statistician have felt little difficulty to learn R and do some analysis using R. But now I wish to present that R also can be utilized as a menu driven in a menu driven fashion. Okay, so I'll be taking one data set, that is a low birth weight data set, which is freely available. I will make use of the variables, and I'll demonstrate different possibilities and in what better manner we can visualize the data, we can conduct some analysis. Particularly, my focus will be on exploring the data available in the data set in the form of a data visualization. Okay, rather than doing some advanced techniques, all these things, how we can frame several questions on our own when we have a data at hand. So this kind of a orientation is much needed for the budding statisticians as well as any learner who wish to do some sort of a statistical analysis. Okay, now let me share my screen. First, I will give a glance about what data set contains. Then I will take you to in R, and then with 2 lines of R code or commands, how we can work out the entire analysis. Okay, now I'm about to share. A second, please. Okay, hope you are able to see the Excel sheet.
Yes,
okay.
we can see, sir.
Yeah, so this is the data set what I have, what I'm trying to take, and what I'm taking today for this demonstration purpose. This is the variable which contains the category where the baby is of normal weight or whether the baby is of under low birth weight, and several characteristics relating to mother. Several characteristics relating to mother are also recorded, like smoking status, race, age, and this is the weight of the mother in LBS, and then height of the, hypertension, whether the mother has hypertension or not, and this is the baby's weight in kilograms. Okay, now just with the simple, these are all the what we say variables that are available, and there are some other variables but I have trimmed so that with the existing variables we can work out some in beautiful visualization. Now, how many categorical variables do we have here? We have low, that is status of the baby, where normal weight and underweight, and smoking status of the mother, whether she is smoker or not, and then race of the mother, whether white, black, or other thing, and age of the mother, and this is the weight, and then hypertension, not hypertension. Fine. When we at first glance, what we need to do. Okay, the question comes, what sort of analysis or what sort of objectives that can be framed using this sort of a thing. Immediately when I say this is the status of the baby, for most of you, for most of us, it will flash in our mind that we can construct a classification model. That means using the status of the smoking, race, age, low birth weight, weight of the mother, high hypertension, presence or absence, and baby's weight, we can easily define whether the baby belongs to having these many conditions of mother characteristics. Can we predict the class of the baby, whether it belongs to underweight or normal weight? That is a classification problem that comes at the highest level. Come down little lower, what we can do. I'm interested to see the following things. Number one is that how the hypertension of the mother will impact baby's weight. That means if the mother has a presence of hypertension, at the same time mother is having a habit of smoking, then how it will impact the baby's weight. Does it make any sense? And what is the association between the baby's weight, which is divided into categorical variable, that is normal weight, underweight, with respect to smoking and with respect to hypertension? So these many questions can be floated as for a verification purpose, and whether the data, first of all, before doing all these things, first of all, we need to see whether the data is symmetric or not. Data of what? My primary interest comes with baby's weight, because that will give me a decision that whether the baby is of normal weight or underweight. Okay, now thereafter, once baby's weight is low or normal, then a connecting question will come that what made, or what are the factors that affected, what are the factors of the mother that affected the outcome, that is the baby's weight. Okay, these are all some general discussions that we can make out of this kind of a data set. As I said, my first focus, my primary focus will be on visualizing the data using, making use of the variables. Okay, now let us move to R. So this is the one line of R code which will help us to take us into, which will help us to go with a menu driven approach in R. So most of you all aware that how to install a package. You can go to this tab, go to package, click on install button, where you will get this kind of a dialog box or a wizard where you type RCMDR. RCMDR stands for R Commander. Okay, now click on this R Commander, and by default check in this install dependencies and click on install button. So the package will get installed. Since I have already installed that package, I'm not doing that. Now the way to call the library, the way to call the package, the way to call the package is library of, and within the parenthesis you need to give the package name. So I already said RCMDR. This is, I'm creating a comment here. RCMDR stands for R Commander. R Commander. Okay, now we have to take this library RCMDR and run it. So it will take a while where it will load some related packages. Okay, like car data, car sandwich package, and different packages. It will take a while to load, and once all the features are loaded, a separate window will get open. You can see in a highlighted orange color that a separate window got opened. Okay, where this is what we call R Commander window, where all the options, this is the first look. This is the first look of R Commander, where you can see the menu. Okay, now as usual, file contains how to open a script file, how to save a file, how to store, and how to exit. Okay, you can set different options are there. Recently, I started exploring this R commander. There are a lot many options to explore, but what and all I have explored, I'm trying to share with you. Okay, and edit as usual, cut, copy, paste, all these things, and data. Now here in this, you can have a new data set, you can load a data set, you can import what sort of a support that our environment will give us to load the data set. You can load an URL. Okay, some Kaggle will give a URL of a data set. In some website, you say machine learning repository data set, you will get a link of the data. So just take that link and load the data. You can directly import SPSS file. You can directly import SAS. You can directly import Minitab, and our friend which comes along with the data analysis support is Excel. Okay, for a statistician or for a learner of data analysis, the basic platform is Microsoft Excel, like data cleaning, data editing, basic data analysis that can be learned very easily. That is what is Excel. Okay, and we can have data in packages, list the data sets that are available in the packages. We can list from there, we can pick up and do the analysis of your requirement. What are the active data sets that are available? Once you load the data set, automatically you will come to see here. Okay, what variables that has, we will see that. Okay, and now go to statistics. It's like a big supermarket. You have a lot of options, lot of pop-up menus, okay, where the bunch of statistical techniques are available, like summaries, lot many things you can do. Numerical summary. One of the advantages that I noticed with a little exploration of R commander is that if your data set contains is a combination of qualitative and quantitative, when you click on the numerical summaries button, it will display only the quantitative variables, not all. Likewise, whatever the test for normality, it will display only quantitative. Automatically, it will restrict it will create a self filter that if you are doing any statistical test based on a continuous measurement, the qualitative variables will not be displayed in your pan. That is one nice thing that I have understood. Okay, I mean observed. Frequency distributions you can generate, counting missing observations you can do, and log like this. Contingency tables you can create two-way, multi-way. Generally, we do all these things in SPSS, like custom tables, creating a custom table of our own design. Okay, and then means we can do single sample t-test, two sample t-test, paid, one-way, two-way, repeated measures. Proportion, single sample proportion, two sample proportions, variances, two sample variances, several variances, and then assuming Leven's test, like non-parametric. As I said, no, each pop-up is having a bunch of statistical techniques that can be applied. See, at the high end, multivariate techniques like dimensionality reduction techniques are also available. And you can do confirmatory factor analysis. What do you mean by confirmatory factor analysis here? That is structural equation modeling. Once the components are identified, thereafter you can create a path analysis, path diagram. From there, you can estimate the loadings and you can speak about the relation between the uncorrelated factors and how they are associated with the final outcome. And you can do a cluster analysis, all sort of a cluster analysis are there. So far, I have not ventured with advanced techniques. Okay, you can fit models, linear regression, linear model, multinomial logic. Generally, for a graduate program, these can be given as a case studies so that students can explore, and we can also learn that what options are available when we write with a code, when we do with a menu driven, what we miss here, what we get additional input here. Okay, and not only this menu driven, once we do an operation, our code will get displayed in this R script area. In this area, the script or the R code, which is used to execute the required menu driven steps, that will get displayed here as we get in SPSS syntax. Okay, now graphs. What sort of a graphs we have? We have dot plot, histogram, And another thing is these are all disabled now. Once we load the data only, the option, okay, models. Here, two different steps. If we want to build a regression model, first we have to develop a model using this option. Then we have to come to model. Then you have to see stepwise model selection. We have to hypothesis testing of the regression model and comparing two models. All these things have to be done here. Okay. And especially for statistical background, you can generate random numbers using, see how many continuous distributions are embedded. Okay. Like normal, you can generate normal quantiles, probabilities, you can plot a normal distribution, you can extract some sample from the normal distribution. Okay, similarly, the same four options, generating quantiles, probabilities, plotting of distribution, and sample from from any distribution is listed for almost 12 to 15 distributions. Similarly, when it comes to discrete, the most widely used distributions like binomial, Poisson, geometric. Here also you can see quantiles, tail probabilities, and then hypergeometric probabilities, plotting and getting a sample from a hypergeometric. These I have to explore. Okay, I should explore, and I have just seen an outline with respect to normal distribution. Okay, and here what you can save or commander options. Okay, and you have some other options that we can do. Fine. This is a quick glance that what a menu contains in our commander. Okay, now let us load the data set, what we have discussed before entering into the R studio. Okay, now let us go to data, import data, and I have stored the data in Excel file. It will show the name as dataset. Directly go to OK. Now it will open a wizard window. I have to choose my file. I have stored my file on the desktop in the folder of ISPS workshop talk March 2022. So this is my database. Okay, before that, actually, I did a wrong thing that we should close the Excel file. 1 second. I will redo that. If not, it will hang. 1 second. Just give me time that, yeah, it got closed. Yeah, now, yes, we have to close the Excel file first, that I have missed to mention. Click open. Now, see the code. Dataset with the name dataset. Read Excel. This is the path. And then row names false, header equal to true, NES or empty, from where sheet LBW. The same what we do in loading an Excel file, the same is that. But it has created an ease to just how to load the Excel, data into, importing data into Commander. Now, once you do that, you can edit the data set. There was some error. It was not 22. It should be 25. I can edit. Okay, you can add a row. You can add one more entry, or you can add one more data. That and all can be done here. Okay, but in R, what we do, edit of the data set. Generally, we do like this. Just with the click of a button, we can get that. Okay, now I have not changed anything. And now what I do is we click on the view data set. Now this, when you click on the view data set, here we cannot edit. Here we cannot edit. Just it's a view that to see how many variables are there, whether all the loadings are done properly or not. Okay. Now, as I said, let us go for a graph data visualization. I'll try to explore. I'll try to show you that what sort of options that can be done. Basically, we start with a histogram. Let us do that. Histogram of what? I wish to go with a baby's weight. See here, as I said, only for what type of data we plot histogram? For continuous type of data, for quantitative. Okay, now see, there are 6 variables in the data set. There are 6 variables in the data set. Of these, age, baby's weight, and mother's weight are quantitative. So only those variables are listed here. Now let me take baby's weight. Now don't touch any other option, then just click OK. Or okay, let us go, we will generate a basic plot, then we will go addition by adding that. Okay, now we got the histogram. But is this fine? We need aesthetics, like what is the exact axis labels, title, coloring, all these things. So what we do is, see here you got width. This is the command which is used to develop that histogram. Now let us redo that by changing some options. Okay, now axis label, baby's weight I put here. Y-axis I give frequency. And graph title, let us take distribution of baby's weight. That's quite easy for me. And what do you want on axis scaling? I want frequency, you want a density, like this. Let me put OK. Now see the difference. See, I got the difference, that distribution of baby's weight, frequency, and this thing. Okay, and now let us redo with a slight change. Histogram again by plots. Plot by groups is another option. Okay, using what you want to divide the entire data of baby's weight with different groups. I want to see the baby's weight of mothers who have a smoking habit and who do not have. I will add that and click on OK. See, I got a partitioned graphs where the first panel, in the 1x2 panel, okay, sorry, 2x1 panel, 2 rows and a single panel column. First row, first cell has a distribution of baby's weight where mothers do not have a smoking habit. Now what we infer, there are, even the same range is maintained, scale is maintained. What we interpret from this, there are a high number of counts. The count is high at the average of 2.5 kilos to 3.5 kilos. The baby's count is high. Whereas when you take the average weight of 2.5 kilos, that is the normal weight of the baby, the count is less. That means that somewhere there might be an influence. There might be an influence of smoking on its effect on the baby's weight. This is a description. I'm not giving an evidence here. This is just an observation, notable observation. Okay, let us try to go with a different version. This is not fine for me. Let me go with a scatter plot or a box plot. I'll come to box plot later. Let us go to scatter plot. Okay, see here also, for what scatter plot we do, it's a continuous variables. Again, only we have a 3 continuous variables in the data, so that it has listed only this thing. Now let me see, because mother's weight influences on the baby's weight. Let us take, I will take x-axis mother's weight, y-axis baby's weight. You see, one more instruction it is given. Pick one, because it's a 2D graph, one variable at a time. One variable at a time. Okay, now let us go to options. Lot many options are there. Okay, where you want the legend? Top right. Let me put on the top right. And what do you want? Least square feet? Okay, I'll get here. Okay, and then what is on x-axis? Let me take mother's weight. I can put, since we have done with the previous graph, I will move further. And then this is baby's weight. Graph title, relation between mother and baby weights. Let us put. And point size you want to decrease or increase, you can do. The point that will get depicted on the XY coordinate that you can control. Okay. And let us start with this. Okay. Now see, I have asked it to fit a straight line. That is not of meaningful, but just to explore the option. Now see, this is the mother's weight and this is the baby's weight. So higher the mother weight, maybe some sort of a, even lower mother weights have the higher, something like this. Okay. Now, next question comes. For every operation, we are getting a code here. For every operation, the code is getting generated. Syntax. Okay. Now, one more question will come. You have done taking x-axis baby's weight and mother's weight. Now, can I include smoking status or hypertension of the mother? Then how my graph will look like? Okay, let us see that. Scatter plot. Now there is an option here. Plot by groups. Click on that. Let me take hypertension. Plot lines by group. Yes. Click that and press OK. Now see. Blue color where the mothers have hypertension. Pink is where the mothers do not have the hypertension. Okay. There are very limited samples where the mothers have baby's weight is more than 2.5 kilos, whereas you can see a lot many samples where the mother do not have the hypertension. So this makes some sense that the clinical factors what mother has might impact the outcome, or weight or any other characteristic in the baby. Okay, there are a lot many characteristics. I'm not concluding here. I'm not giving a decision making here. Just I'm trying to explain what modalities we can do in R Commander. Now let us do another thing. Plot of means. I want to see. When I see the plot of means, generally line whisker plot we do. Okay. Now go with hypertension. Pick one or two. Let me take two. Smoke. Pick one outcome variable, baby's weight. Again, options. You can do x-axis, y-axis. How the error bar should be. Whiskers. To create a whiskers on the line, you can do standard errors. Yes, I want a standard errors. Okay, then continue with that. See, I got it. For doing this, we take a lot of time in Excel. Hope the people who draw this line whisker plot in Excel, they understand the time consumption. Okay, so this is for, and you see, for hypertension, let us do with a simple model. Graphs, plot of means. Let me take only hypertension, smoking or hypertension, and do this. Say this. Hypertension, average baby's weight for the mothers who have the hypertension, average weight of the baby where the mothers do not have the hypertension. There is a proper inclination. There is a vast difference. Even the confidence interval is not that wider in the baby's weight whose baby's weight of mothers who do not have the hypertension. Whereas if you see the variation in the babies where the mothers have hypertension, there is a scatterness in the data points. Now, what we do, like this, we can observe a lot many plot of means. I will add one more by holding the control key and click on this. This is a different combination of line whisker plot. How? See, I have added one more factor to develop two different line whisker plots in the same graph. That means this is one categorical variable. This is another categorical variable. Now, how to understand this? This is the triangular one is the mean weight of the babies where mother have the hypertension as well as smoking. Okay. Now, mothers have hypertension, but they do not smoke. The average baby's weight is around this. And mothers who do not have hypertension, but have a smoking, but impacted a lot on the baby's weight. No smoking, no hypertension, average weight of the baby is at the higher level when compared to these things. Now look at the dotted line. Look at the dotted line that having a smoking habit or a hypertension, somewhere it is associated with respect to the outcome in terms of weight of the baby. Okay, so I again repeat that I am trying to explore in what different complex graphs with a meaningful presentation we can do. Okay, now like this, we can go with 3D plot. Okay, now let us generate that also. Age, pick 2, baby's weight, and here pick 1. Okay, now I got a 3D plot. This is RGL device. You are able to see this RGL device? This is what we call rotated graphic libraries. What do you mean by that? We'll witness that. What do you mean by that? I can rotate this. Are you able to see the rotation? How my mouse moves? You can see where the surface of the data points lie. Generally, we'll try in a classroom environment or in an online, will be more difficult that we take our fingers. This is your x-axis, y-axis, z-axis, or some sort of a big line of R code to demonstrate this. Okay, big line of R code to demonstrate this. Just with a click of a button, I got a rotatable scatter plot where I can show, I can zoom in. Are you able to see? Zoom in. And another important thing that comes is, basing on the measurement of the variable, the diameter or the size of the plot that balls depicted will vary. If lesser weight in mothers and lesser weight in baby, a small, you can see here, this dot. This is a smaller dimension, whereas this is a bigger one. So the size of the data points depicted on a 3D coordinate will also vary according to your data set. So like this, I can zoom in, zoom out. I can see in what area it has. Okay, so this and all things that can be generated. And now, may I know how much time do I have?
Yeah, you have time till 4:50, sir.
Oh, okay. 10 more minutes are there. Thank
Yes,
you.
sir.
Yeah. So I will show you some other things. Let me fit a regression line. I think that will come here. Okay, let me explore in this only. Yeah, box plot. Let us see the box plot. Okay, now age, or let us take the body, baby's weight, again plot by groups. I want to see with respect to hypertension. Click on OK. Let's see. The average, the median baby's weight is slightly higher in the mothers who do not have the hypertension. This is what initially we need to play with all the variables. We need to explore. Sometimes this kind of analysis will help us to define an objective that can't we compare? Can't we compare the mean baby's weight between hypertension and non-hypertension mothers? We can apply. If it is normal, we can apply parametric. If it is not normal, we can go for non-parametric. So just a click of a button. Okay. And if you see, the whiskers also is little wider and large many data points are there and they are equidistant almost. One advantage of box plot, most of you might be known, but let me recall that this median be at the center of this box. Normal, symmetrically distributed, and even if you see the whiskers, they are equidistant, almost equidistant from the median. And this median line, dark line, horizontal line, which is parallel to x-axis, is also equidistant within the box. Even coming to the hypertension data, you can see this is slightly on the left side, but fine. Looking at the whisker, data is slightly distributed, deviated from the center, but still almost normality we can assure. Okay, so like this we can do, and I'll try one more thing that I want to see the hyperplane on a that will come once. Let me try that regression. Let me put a regression line, like can I estimate responsible, can I estimate baby's weight using the mother's weight. I will, let me put as a trial one. Okay, now click on OK. Now trial one is not a valid name because space is not allowed. That's good. Sometimes we have to do mistakes. Let me put like that only. Now we got the model here. You can see we got the model. So this is the 2369.184 plus 4.430 into mother's weight. And this is about R square is too low. That means correlation is too low and we cannot depend upon this kind of a model. Okay, but my attempt was something else. That's fine, no problem. Let me explore with other options that are available. Let us try to work out with plot normal distribution using what I can specify some mean. Let me take 12.57 with standard deviation of 1.15. Okay, plot density, what do you want? Let me take a plot density. Okay, and then click on OK. Now I got a distribution. Okay, so I can create the density patterns of different modalities. And let me take samples. Let me take samples from the normal distribution. Again with mean 12.57. Let us take the same thing with 1.15. And number of samples in row. I need how many rows? How many samples? Let me generate 100 samples. How many samples? Only one sample. And number of observations are 100. Add to data set. What do you want to add? And just let me take the sample means. Now that is added to the normal sample. Now you can see view data set. Yeah, you can see here. This is a sample 100 random samples are generated. Hope you are able to see this, right? Samples are generated like this. So generating samples and like this you can do with different distributions. Okay, and I was supposed to, yeah, in a scatter plot matrix there is one more observation. Okay, let me first enable the data set. I can import multiple data set. Okay, all will be in a active mode. I can choose the data set of my requirement and carry out the analysis. So random samples is another data set which I generated now, and data set was the data which I have imported earlier before generating a random sample. Let me set data set as a active data set and click on that. Okay, now let me go to graphs, scatter plot. Okay, I was about to show something that, yeah, this one. options, in options, you have a plot concentration ellipse. Okay, let me take point 5, 50% concentration, because when you work with a bivariate structure, the ellipsoid will tell the concentration of the data points, how many are within the 50% of your contour. Okay, so that you can see in this, I think somewhere. Oh, I have to choose the variable. What happened? I didn't get that. 1 second. Now, I think somewhere I have not done it properly. Yeah, options. Yeah, let me select the plot concentration. Let me put with 50% thing. Yeah, I got this. Within the 50% region, confidence region. Okay. And then how many data points are, and this is the darkest point is nothing but the thick point is nothing but your mean centroid value. Likewise, I can develop different contours. I can develop different contours with 0.5, 0.95. Okay, let me do that. See, different concentrations can be developed, which will make use of the data points and then spread it across. Okay, and these are extremes. These are all extreme data points which are far away from your centroid. Okay. Now, yeah, this is what I wish to present. I think I'm done with my time. Let me be on time. Okay, so this is what I wish to present, explore, and share the thoughts on the utilization of a menu-driven function or a package that is available in R. Okay, so thanks for patience listening. And if you have any queries or any kind of a discussion, you're entertained. Yeah.
Thank you, sir. Thank you for your inspiring speech. Back to sir, Patel sir.
Yeah.
Thank you, sir. Thank you very much for the short notice that you pre-lecture that you have delivered. So for your kind cooperation, sir.
Thank you.
Thank short notice.
Thank you.
Sir.
Thank you. Thank you.
I thank all the participants and all the speakers, those who have delivered and enlightened all the participants. Now, tomorrow that will join for the conference. There is no separate the valedictory that because the continuation program as that. Thank you to one and all.